users Radhehari and Hemvati Nandan Boguna College and organizing committee and my own behalf, I once again take this privilege to heartily welcome you all and feel delighted by your presence. Thank you for joining us in the National Virtual Conference on Recent Advances in Analytical Techniques 2020, that is RAAT 2020. On the second day, I once again extend you a very warm welcome. The analysis of a material is an integral part of the scientific research and technology development. A precise information and knowledge of different characterization approaches together with the advancement in the characterization techniques is essential to any scientific output. This prestigious conference is a very much dedicated to the advances in the analytical techniques and is going to offer a beautiful platform to our scientists with different background. Very attractive to our students and young researchers who will get glimpses on new approaches of material characterization systems. So now we are proceeding for our next session, the technical session day 2. I hope all of you delegates and participants from different parts of the country will enjoy the presentations and discussions that are going to be take place in this session. Now, first of all, I welcome today's our chairpersons of the today's talk, plenary talk, is given by Professor Mangala Joshi from IIT Delhi. So today's chairperson, D.D. Pathak, Professor D.D. Pathak, head of the Department Applied Chemistry, Indian Institute of Technology, that is IISM Dhanbad. Jharkhand, he is PhD Chemistry from Research School of Chemistry, Australian National University, Canberra, Australia, 1990. Postdoctoral postgraduate degree in chemistry in 1981 from Agra University, Agra. India bachelor degree BSc from 1979 from Agra University, Agra. Research experience about 33 years. Number of PhD guided 10, currently enrolled for PhD degree MPhil and guided applied chemistry bar 12 students. Teaching experience is 26 years of undergraduate and postgraduate student at Indian Institute of Technology, Dhanbad, and other institutions. He has 57 publications. I welcome you, sir, and request you to embrace us with your presence by taking seat as a chairperson for this technical session. Second chairperson of this session is Professor Ajay Taneja from Department of Chemistry, Dr. B.R. Ambedkar University, Agra. Welcome you, sir. Dr. Ajay Taneja is presently working as a professor and head of the Department of Chemistry, Dr. B.R. Ambedkar University, Agra. He also holds the post of Dean Research in the university. He has more than 26 years of teaching and research experience. His research interest is in the environmental chemistry and air pollution. He has guided more than 17 PhD and 26 MPhil students. He has co-authored more than 130 research articles, 5 books, 5 book chapters, and 5 research reports. He is life member and fellow of many professional bodies and is holding the post of Joint Secretary, Indian Council of Chemists, India since 2006. He is also a reviewer of many international journals. He was also awarded Father Ratier Matthews National Award for Innovative Teachers for the year 2001 by All India Association for Christian Higher Education. He is a resource person of Commerce and Industry of India. New Delhi for environmental sciences in the academic staff college of different universities and science and technology schools in earth and environmental sciences. He is also a consultant to the task force set up by Central Pollution Control Board to set up standard and SOPs for indoor air pollution in India and have traveled 14 countries for academic purposes and have participated in many national and international conferences and workshops. His expertise is the field of monitoring different types of pollutants in indoor and ambient environment, as well as chemically characterizing the indoor and outdoor air sols. I welcome you, sir, and requested you to embrace us with your present by taking seat as a chairperson for this technical session. I welcome you, sir. I'm requesting you, sir, to introduce our today's plenary speaker, Professor Mangala Joshi from IIT Delhi. I requesting you, sir, please introduce. Please.
Can you hear me? Hello.
Sir. Yeah.
Thank you, Dr. Upadhyay, for nice introduction. And first of all, I would like to thank organizers, Dr. Kumar Upadhyay, Dr. Ashish Kumar, for giving me this opportunity to.
You are unmuted. You can unmute yourself, sir. Yeah. Continue, sir.
Yeah. Let me first of all thank you, organizers, Dr. Shiv Upadhyay, Dr. Ashish Kumar, for giving me this opportunity to chair this session and introduce the plenary talk speaker, Professor Mangala Joshi, who is professor in Department of Textile Technology, IIT Delhi. She specializes in polymer fiber science and technology and is an alumnus of IIT Delhi, having obtained her MTech and PhD degrees in polymer science and technology in the year 1986 and 1992, respectively. Her current research interests are nanotechnology applications in textiles, polymer nanocomposites, fibers and coatings, nanobiomaterials, nanocoatings and nanofibers, bioactive and functional textiles, and environmental friendly technologies. She has been involved in investigating several sponsored research projects funded by DST. One of the mission was Nano Mission. Government of India Aerial Delivery Research and Development Establishment, ADRD, which is in Agra. It's a famous lab of DRDO, Department of Biotechnology and Industries, both national and international. She is the recipient of third National Award for Technology Innovation under the category of R&D in the field of polymer science and technology, awarded by Ministry of Chemicals and Fertilizers, Government of India. She is also coordinator of research vertical on smart and intelligent textiles under the Joint Advanced Technology Center set up by IIT Delhi by Defense Research and Development Organization under Memorandum of Understanding. She is principal investigator of several research projects, especially development of hull materials for aerostat and airship envelope under GATC. She is also member of Nano Research Group at IIT Delhi working on bioactive nanocomposites. She holds a US patent and also worked on on-site project from Yale, India on multifunctional hybrid polymer nanocomposites. She has guided many PhDs and has more than 90 refereed publications in international and national journals and about 100 plus papers in various, she has presented various international and national conferences. She is also a co-opted member of Expert Committee on Engineering Sciences in SERV DST Government of India for the year 2015-18 and 2018-2021. She is being member of Research Advisory Council of ADRD, DRDO, DMSRD Kanpur, North Indian Textile Research Association, Ghaziabad, PhD Institute of Advanced Research, Coimbatore. And she also holds the post of executive member of professional bodies such as Polymer Processing Academy and Fiber Forum India, Textile Association of India. With her high-profile data, now I welcome Professor Mangala Joshi to deliver her plenary talk related to recent advances in analytical techniques 2020, RAAT 2020. Madam, please. Professor Professor Manga Joshi, now I invite you to give your plenary talk.
ओम जी, ओम जी,
हेलो जी सर।
ओम जी, मंगला जोशी मैडम को अलाउ कर दीजिए।
जी ये सर अलाउ किया हुआ है।
हाँ, थोड़ा सा स्टे रहिएगा तो वो थोड़ा सा कनेक्ट हो
आ,
जाए अच्छे से।
मैम मैम शायद 2 डिवाइस से कनेक्ट है, एक डिवाइस से कनेक्ट होंगे तो ज़्यादा अच्छा रहेगा क्योंकि इको हो रहा है ना सर।
आप फोन कर दो ना, फोन में नंबर दे दिया आपको, फोन दो आप।
ठीक 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 है, बता दें।
हाँ जी मैडम, मैं यहाँ बिल्कुल। Yeah, ma'am, your screen is visible now. Ma'am, your share content is visible now, and unmute yourself, ma'am. Unmute yourself. Mangala Joshi, ma'am, I'm requesting you unmute yourself. I'm requesting
Hello?
all of you to. Yes, yes, ma'am.
Did you call me?
Hello.
Hello, Shiva. Did you call me?
Yes.
Yes. Okay, I'm
Yes,
here.
ma'am. Yes, ma'am. Are you joined here?
Yes, I have joined.
Thank you. Thank you so much, ma'am. Thank you so much, please.
Oh,
Okay.
oh.
Be patient. I'm requesting all of you. She's on call with technical team now. So I think she will. Wait 4 to 5 minutes. There is connectivity issue. Please.
हेलो जी मैम बोलिए
हाँ हेलो प्रेजेंटेशन दिखाओ स्लाइड्स
Ma'am, your file will be shared by Dr. Ashish. Wait for 2-3 minutes, please. Are you listening, ma'am? Me?
Yeah,
Okay. Yeah, Dr. Ashish will share.
I have sent you a presentation, so if you can.
Yeah.
Yes, ma'am. Yes, ma'am. Please wait, ma'am. Only 1 minute.
Yeah,
Your presentation is forwarded to Dr. Ashish by me. Dr. Ashish, are you available? Dr. Ashish.
and problem.
Yeah. Ashish.
Bandwidth आ रहा है. Bandwidth आ रहा है. खुला.
So I'm requesting all of you, all the participants, wait for 2-3 minutes. Dr. Ashish will share the screen, Professor Mangala Joshi. Then she will talk on your presentation. I think in 2-3 minutes, Dr. Ashish will share your screen, ma'am.
Correct.
Hello.
Yes, ma'am, you are audible. You can start your talk, please.
Uh, you are. I am audible.
Yeah. Exactly, you are audible,
Okay.
please.
Okay.
Yes,
Okay. So
yes, ma'am.
good morning. So good morning, everybody. And I am really sorry for this technical glitch. I think this is, I think, because IIT net is, I think, having some low bandwidth problem today. Uh, so I'm first of all thankful to the organizers who have invited me to give this talk on characterization techniques for nanotextiles, especially to Shiv, who followed it up with me and convinced me because to give this talk. So I have chosen characterization techniques for nanotextiles because this is an area where I am working currently. So next slide. Next slide, please. So our research group basically is looking at polymer nanotechnology and creating advanced textile materials from it. As you know, all textile materials are polymeric in nature, whether they are natural or synthetic. So we do a polymer nanotechnology to create advanced textile materials. Our areas of interest are basically defense textiles, biomedical textiles, and multifunctional nanocomposite fibers and films. Yeah. We have been doing projects from different agencies like DRDO and GAIL. I am proud to say that in 2012, 2013, we were awarded the National Award for uh, excellence in polymer science and technology field. And in this award, we worked on polyurethane nanographite based multifunctional coatings for defense applications. Next slide. So if you look at nanotechnology, I think nanotechnology is impacting all fields of science and technology, but textile engineering, which is one of the oldest, was I think the first one to come out with a product based on nanotechnology. And nanotechnology is proving to be a new tool for improving the performance of materials, including polymers and textiles. And definitely we are seeing it as a driving force for change and innovations in the textile industry. And I'll give you some examples of it to show that. Next slide. Next slide. Can you hear me? Next slide, please.
Dr. Ashish, please move your slide, please.
Yes, already moved.
Yeah. So textile industry is one of the textile industry is one of the premier beneficiaries of advances in nanotechnology, and because textiles has a very large consumer base and it has a significant impact on nation's economy. So estimated textile production, this is the data for 2010, but this is the trends are the same. So we are expecting in different areas nanotechnology based textiles are going to come, including industrial applications. More and more applications we are seeing in medical and hygiene, transportation, sports and leisure wear, environmental protection, and protective clothing. Next slide. So everybody in the forum, I think everybody knows what is nanotechnology, but I still want to start with what is nanotechnology. All of us know that everything is made up of atoms, and atoms build molecules or form materials. So what is nanotechnology? It deals with the manipulation of atoms and on molecules to produce materials, devices, and even machines in nano size. And most of us, nanotechnology is called as a bottom-up technology because as you can see in the figure, this is micellar aggregation. So, if you look from left to right, all the micellar units, they don't need anything just because of the hydrophilic interactions. Beyond a certain concentration, if they are present in water, they self-assemble into a particular structure. So nature's nanotechnology or bottom-up technology is something where we start from elementary materials and they self-assemble due to very basic features like hydrophilic hydrophobic interactions or other kinds of bonding forces, and they aggregate because there is nothing like there is no technology where they are putting atoms into one, so they are self-aggregating depending on its properties. On the other hand, top-down technologies are such, most of the man-made technologies are top-down because we start from the bulk material and create. Like, for example, if you want to make a small iron nail, we extract iron ore, then from iron, and then we start making into, nails. So this is a man-made top-down technology. But if you look at nanotechnology is mostly inspired by bottom-up technology. And this is actually learning from nature. Next slide. So what are nanomaterials? I mean, the most of the excitement in nanotechnology are the nanomaterials. By size classification, they range in the size of 1 to 100 nanometers. And most important is that the properties of materials change when they go in this nanoscale. So the nanoscale material properties are different from their corresponding bulk properties. And the major reason for this is because as you reduce the size of the particle from 10 centimeter to the same volume is same to 1 mm size to 11 micron size and then 1 nanometer, you can see the surface area to volume ratio exponentially increases. And as you know, all the atoms at the surface are always at a higher energy. So if if the surface properties become dominant, so the material properties also show a different than the bulk properties. And this is the main reason why nanomaterials show such excellent properties, which we are trying to exploit to impart to polymers and give them certain functionalities. Next slide. So if you look at, I will be dealing mostly in textiles. So you can see that we are using different kinds of metal oxides, nano titania, nano aluminum oxide, nano zinc oxide, nano magnesium oxide, nano silver, because of their various properties. And we are applying them on textiles and trying to get different properties like self-cleaning, antimicrobial, UV protective, anti-static, and stain resistant. The advantage of using nanomaterials in textiles are that because their size is so slow, so they are transparent to the eye. If you are actually able to disperse them at nano level and apply on textiles, they add a physical property performance, but there is no effect on the clarity of the coating. So this is one of the major advantages, and you have to use much less material when you are using them in nano size, because materials are more reactive even at low concentrations. So that is the advantage. Next slide. Next slide. Yeah. So, when I joined IIT in 2000, this field was just coming up, and we took an initiative of applying nanotechnology in textiles. And, we feel that the first generation of textile fibers like cotton, silk, and wool, to second generation of fibers, synthetic fibers like nylon and polyester, then third generation of high performance fibers like Kevlar, Dyneema, carbon, etc. And now I think the fourth generation of textiles is going to be smart and intelligent textiles based on nanocomposite fibers, nanofibers, nano coatings, etc. So if you look at our research, then we are basically working in 4 domains: nanocomposite fibers, nano coatings, nanofibers, and nano finishing. And I'll give you some glimpses, and then I'll come to how the analytical techniques are helping us to do the research in this area. Next slide. Next slide. Yeah. So this is one beautiful example of mimicking nature and getting that effect on the textile. If you see I think everybody has seen the lotus leaf and how it floats on the water, and if there are dewdrops, if that is not absorbed by the leaf, but it forms a droplet, and as the leaf is moving, the droplet just rolls down. So it is some kind of a self-cleaning effect. That means because when the water drop rolls out, it takes away the dirt with it. And lotus is, as we know from our scriptures, that lotus is known for its purity, that it remains in that pond, where there's dirty things, but the lotus remains pure. So that self-cleaning property is also known as lotus leaf effect. And this lotus leaf, if you see under a microscope, scanning electron microscope, then you can see that it is not a plain surface as it appears to our eyes. And there is something in the surface structure which is giving it this property. So I think if we can have the similar kind of effect on textiles, that we can make self-cleaning textiles, that by just washing, the dirt will go away. So next slide. Next slide. Next slide. आशीष, आप थोड़ा सा कोऑपरेट करिए.
There is some network problem. Stay tuned. No problem, please.
So I can keep explaining this figure. So if you see, on the left hand side, the fabrics, yeah. So I think, yes. So thank you. So, if you look at this lotus leaf, and I have shown in a bigger picture how it looks under the microscope. So you can feel that actually there are two levels of roughness, micro roughness and nano roughness. And there is an additional property which I'll just tell you. So these papillae, which you can see on the surface, are creating micro roughness on the surface, and on top of each papillae you can see small dots. I think you can see all very clearly, and these are nanoparticles of wax which have been deposited on the papillae. So this is creating, now wax is also hydrophobic. So there are two things here: creation of roughness on the fabric and having a hydrophobic material, which is a wax. In this case, natural wax nanocrystals are deposited on this papillae. Now this kind of a feature gives the lotus leaf a super hydrophobic effect. Super hydrophobic, when we say, when the contact angle of water, when it is 90 and above, we say the material is hydrophobic, and when it is 90 and below, we say hydrophilic. So the generally this contact angle of the super hydrophobic materials like lotus leaf, it has been measured and it has come out to be around 160, 170. That means water will fall on it, it will just form a droplet, and it can just roll down, and while rolling down it will take the dirt along with it. So if we can create this kind of an effect on the textile, then there will be so much easy for us to keep the textiles clean. So with this inspiration from nature, many people started doing the research. And why I'm telling you all this, that I'm giving you some examples of research of nanotechnology in textiles and how analytical techniques are helping. So next slide. No, this is previous slide. Next.
Dr. Ashish, this is previous slide. Move forward.
Yeah. So this is a slide, where I am showing the slides of, we tried in the laboratory to create the lotus leaf effect. So this work was done by one of my MTech students in 2008, I'm showing. As you can see, we tried to create the roughness on the cotton fabric using nanosilica, right? And then to give a super hydrophobic finish, we used a fluorocarbon finish, because generally fluorocarbon finishes are used to give a water repellent kind of an effect. So we, as you can see, we have used SEM to see the deposition of nanosilica coated fabrics under SEM. You can see the picture, and definitely we have not been able to mimic the nature. So we can see the nanoparticles deposited on the cotton fiber, but they are not as uniformly deposited. There are some aggregates, but definitely the effect has come. So if you look at the table, then you can see the contact angle. If you just apply a fluorocarbon finish without the nanoparticles, then you get a contact angle of 115 and 118. But as soon as you apply nanosilica and create a roughness on the textile, and then you apply a fluorocarbon finish, we have been able to go up to 132. So definitely we are not very near the nature, but 132, and this fabric was showing definitely a super hydrophobic effect. So this is how we see that SEM, how it's a scanning electron microscope is helping us to look at the deposition of nanoparticles on the fabric surfaces. Next. Next. So similarly, a lot of applications like antimicrobial properties and UV protective properties are also applied on the textiles. For antimicrobial fibers, I think there is now a big demand. Nano silver, nano copper, nano zinc oxide, and nano TiO2, etc. have been used in textiles. For UV protective, zinc oxide has been used to give nano zinc oxide has been used. So a lot of applications of nanomaterials in textiles for giving new properties to the textile materials. Next slide. So, this is another area where I have been working. It's one of my favorite research areas where we are trying to work on polymer nanocomposites. Now, you are very much aware of polymer composites, and polymer composites have done wonders. They have come out as a very strong engineering material, and they are replacing traditional metals and ceramics in many metals, especially in many applications, because of their excellent weight to strength to weight ratio. Polymer nanocomposites are where you are reinforcing the polymer with nanomaterials, which can be of all types, like layered silicates, which are one-dimensional nano, carbon nanotubes, which are two-dimensional nano, carbon nanofibers, and then POS, hybrid POS-like materials, where all the three dimensions are in nano. So these polymer reinforced with nanostructured materials dispersed at nano or molecular level can impart certain of the properties of these materials into the polymers, and at very low concentrations, and without affecting the bulk properties of the polymer. So I think this has been one of my very favorite research areas. So that's why I wanted to show you the slide. Next slide, please. So in this area, I started working on, we in textile, fibers are very important. Fibers are the basic units of textiles. So we thought, like, there are many fibers, synthetic fibers, which are made by melt spinning or solution spinning. So we started working on nanocomposite fibers, and we were looking at enhancing the properties like mechanical properties, tensile strength and modulus, toughness, improving the thermal stability of the polymer, improving the conductivity, whether it is electrical or thermal. And then now we are looking at imparting functionality like bioactive properties or electroactive properties, or improving even the diability. And we have worked with polymers like polypropylene, nylon, and polyurethane with layered silicates as nanomaterial. We have worked with carbon nanofibers, and we have worked with POS, which is actually three-dimensional hybrid inorganic organic nanofiller. And most of my research has gone into this. The basic idea of adding these nanomaterials into polymers has been improvement of thermal properties. So, if you look at this diagram on the left hand side, you see that if you look at the use temperature and if you look the toughness, then ceramics are on very high use temperature, but toughness is low. And on the other side, the polymers are high on toughness, but use temperature is low. So when we have these inorganic nanomaterials put into the polymers, we are expecting to fill the property gap between ceramics and metals. So we have worked a lot on this, and characterization techniques have been very, very helpful to us. So I'll show in the next couple of slides how they have been useful to us. But before I go forward, I am actually very proud to tell you that, see, ultimately, after doing all the research, we can publish papers, but actually the impact on the society comes when we come out with a product. So, one of my PhD students, Anusuya Roy, who worked on a Gale-sponsored project, because it was an industry-sponsored project. So, right from the beginning, she was trained to look at the commercial angle of it. If we are making something, where is the use going it to be? So, right from the beginning, that kind of a philosophy with which we were working. And then at the end of her PhD, then she said, "Ma'am, I want to bring this into an application." So she applied for a startup grant from BIRAC, and she got a 50 lakh startup grant. And we have now a startup company called NanoSafe Solutions Private Limited, which is incubated at IIT Delhi. And recently, when came, and because we are working on antimicrobial technologies of textiles, so we thought, like, we should come out with a mask which has antimicrobial antimicrobial or antiviral properties. So right in May itself, it just took about a month for us to design and develop the RAAT product, and on 5th of May, that was the and yeah. So this is a picture of the mask. As you can see, this is our NSafe mask. Masks are more important than social distancing and staying at home. Of course, all the three things are important, I feel. Uh, this is NSafe is our trademark, and this is a product of NanoSafe Solutions Company. It is a highly engineered triple layer mask with inner comfort layer, then antimicrobial middle layer and outer water repellent layer, and NSafe is reusable up to 50 washes, and each use brings about can be about for 8 to 9 hours. And this mask is something, when it came out in the market, this was one of the first fabric based antimicrobial masks into the market. Here we have used nanotechnology, because to impart the antimicrobial properties, we have used metal nanoparticles. We have given the finish of metal nanoparticles in the middle layer. So application of nanotechnology into textiles and creating an unsafe mask for COVID was something which we are very happy about launching. Yeah, and it has got a very good response also from the customers. Next slide. Our next product in line is also, the technology which we have developed is, we can have this shaker bottle. Now, if you keep water in this container, uh, we have here also nanotechnology is there. We have introduced very, very small amount of copper in the nano form in our plastic bottles. These and if you keep water in this, and if you store for long time, then it gives you antiviral, antibacterial and antifungal properties. So this product is just recently launched, and I'm expecting that we are making more fridge bottles and big containers, and I think this is first of its kind of product in the market, at least we know. So this is all a patented technology. So this is again use of nanomaterials to design products. Yeah. So now I'm coming to, after giving you a glimpse of the technologies that we have developed, I'm coming to characterization techniques which are important for research and development in nano textiles, and I'm going to talk about technologies like microscopy, spectroscopy, X-ray diffraction, and particle size analyzer. Next slide. So if you look at nanomaterial characterization by microscopy, then the following are the important imaging techniques. Scanning electron microscopy is very important. Then energy dispersive X-ray analysis also is very helpful. Transmission electron microscopy and high resolution transmission electron microscopy are important. Atomic force microscopy is also important, and STM. Although STM we don't use so much in our textiles things, but all the other characterization techniques, STM I think mostly physics and chemistry people use. So, but the first four technologies we are using in our R&D. Next slide. So if you look at the principles of electron microscopy, because SEM, TEM, HRTM, everything falls in the electron microscopy range. Why we have to go from optical light to electron beam is that resolution is strongly dependent on the wavelength. Now, because an optical microscope can show you only up to 500 nanometer, whereas an electron microscope go darkest and light atoms, high transmissions. So this is how the images are formed. Electron microscopes are often equipped with instruments very useful, especially in textiles. Most of our imparting on the surface and what kind of materials are going on the surface, what elements are going. So EDX helps us a lot. Then the two techniques of transmission yeah. So if you come to the scanning electron microscopy, I think all of you are chemists. And I'm sure people from having they are in chemistry. Analytical techniques are the most important, but I'm talking of techniques which we use in textiles. So scanning electron microscopy is one of the very important tools. I think no PhD in textiles is complete without giving the SEM pictures in the thesis. So it is that important. So just if we talk about the schematic diagram, then you have an electron gun which gives the beam of electrons, and then you have electromagnetic lenses to make a coherent beam, and then there is the specimen. So when these coherent beam of electrons strikes the surface, then backscattered electrons are released, secondary electron detectors are released, and all these are taken to a sensor which forms the image. So primary detection mode is the secondary electron imaging, and in analytical SEM even the backscattered electrons are also taken into care. The image displayed is a distribution map of the intensity of the signal being emitted from the scanned area of the specimen, and we can go to resolution about 3 lakh times, and we can see up to 3D images. The good thing is we can see the 3D images. The thickness can go up to few nanometers in the sample. Will go more clearly, then I think so this is a simple diagram which gives you the principle. So when the electron beam what it does, now when the electron beam strike the sample data some of it is absorbed. electrons which are below the sample. So basically in SEM, we are looking at secondary electron, and if you go to FESEM, then we are looking at backscattered electrons plus secondary electrons. If we go SED6, then we are looking at the X-rays which are emitted. So this all depends on the interaction of the electron beam with the nature of the sample. Yeah. So how the SEM works? The SEM uses electrons instead of light to form an image. A beam of electrons is produced at the top of the microscope by heating of a metallic filament, as you can see on the right, the picture. The electron beam follows a vertical path through the column of microscope. It makes its way through the electromagnetic lenses. In optical microscope, you use optical lenses, but when you are using an electron beam, you need electromagnetic lenses to focus the beam, direct the beam downwards towards the sample. And once it hits the sample, other electrons are ejected from the sample, and detectors collect the secondary or backscattered electrons and convert them to a signal that is sent to a viewing screen, and similar to the one in an ordinary television, and that's how you see the image on the monitor. Next. Next slide. Yeah. So, now you can see the beautiful pictures of SEM images of nanotextiles. Now, on the top left side, you can see these are electrospun nanofibers, nylon 6 nanofibers, where silver nanoparticles have been deposited. So you can if you now, there is no other technique which can show us so clearly, the nanofibers, what is the diameter and how the nanoparticles of silver have been deposited, whether uniformly or not uniformly, and to what extent. So SEM helps us a lot. So it can go to different kinds of magnifications also. In the B slide, we are seeing the peptide nanofiber scaffold for tissue engineering. So these nanofibers, which have diameter in the range of say about 100 to 500 nanometers, are nowadays a lot of application in tissue engineering. So you can see these peptide nanofibers, and the C figure, you can see a applied carbon nanotube yarn. So SEM has been very useful in looking at this. The below figures are from our own research. So if you can see the first diagram is of a PP filament, just neat PP filament, we don't see anything. But next is the PP clay nanocomposite filament. So we can see some clays coming on the surface and creating some kind of a roughness. Then you have on the below, you can see POS nanofillers, which I was talking about. They are cube-like shaped. And then on the right below figure, you can see when POS is dispersed into a HDP polymer, then how the distribution is. So SEM is helping us look at all these, and this is a very, very useful tools for us for R&D in nanotextiles. Next. So then SEM coupled with energy dispersive X-ray analysis is also very useful, because when we want to scan what kind of elements have been deposited on the surface, it's very useful. This technique is used in conjunction with SEM. And here electron beam strikes the surface of a conducting sample. So that is very important. In SEM, the sample preparation is very important, because our fibers and polymers are non-conducting in nature. So we have to make them conducting by giving a very thin coating of gold or any other material, which makes the surface conducting. But it has to be a very thin coating so that it doesn't disturb the topography of the sample. The energy of the beam, which is typically in the range of 10 to 20 kilovolts, this causes X-rays to be emitted, as I have just shown in my previous slide, from the point of view of the material. And the energy of the X-rays emitted depends on the material. The X-rays are generated in a region about 2 microns up to depth. So if you can see now the next picture, then you can see the process analyzes near surface elements and estimates their proportion at different positions, thus giving an overall mapping of the sample. Now, if you can see on the picture, A is pure platinum. Pure platinum nanoparticles are there. So you can see the EDX peak shows only the platinum peak. Now, in the B sample, it is gold and palladium. So, you can see these nanoparticles, and on the right side, you can see the image. You can see both gold and platinum peaks in the EDAX image. Then C is gold and silver. So all these have been deposited on a cotton cloth with silver nanoparticles. So you can see that the EDAX graph shows peaks for both gold and silver. So this kind of technique, SEM with EDAX, helps us to really confirm what kind of elements have been deposited on the surface of the textile. Next. Now I come to transmission electron microscopy. So here the basic principles are same as a light microscope, but instead of optical light, here we are using electrons because electrons can beam can depending on the accelerating voltage, and it gives very low wavelength light which matches. So that's why the resolution is very high. So we can see very small and smaller things because the wavelength of electrons is on me. Yeah. So, so the TEM operates on the same principles as the light microscope, but uses electrons instead of light because the wavelength of electrons is much smaller than that of light. The optimal resolution attainable for TEM images is many orders of magnitude better than that from a light microscope. Next slide. So if you look at the working of the TEM again, then you have a tungsten filament right on the top which generates the beam of electrons, then which is focused on the specimen by again the magnetic lenses as condensers, and the column containing the lenses and specimen. Now this is very, very important for SEM as well as TEM. The column containing the lenses and the specimen must be under high vacuum. If you do not have high vacuum, then the electrons will get disturbed here and there and they will not be able to focus. Magnetic lenses form the enlarged visible image of the specimen on the fluorescent screen, and then the photographic film, the screen can also be moved aside and image is captured on the photo. So in scanning, we are looking at the electrons which are scattered back, but in transmission, we are looking at what electron beam has been transmitted through the sample. So that is the difference. Next. So this is an image, this is a microscopy technique where a beam of electrons is transmitted through an ultra-thin sample. Now here I will like to tell that in TEM, the most important thing is how good you sample you make. You may need to make an ultra-thin sample. If you don't make an ultra-thin sample or a good sample, your electron beam will not pass through the sample itself. So the major challenge in getting good electron microscopy images to have a very thin section of a filament so that the electron beam can pass through. Sometimes what happens when you are using high resolution, then you are using higher voltage, then sometimes our polymer samples can get damaged also. So we have to take care of that also. So, and this image is formed from the electrons. So here is HR-TEM, you can see high electron resolution TEM microscopy. Here the resolution can go less than 1 nanometer, about 0.8 angstrom. And HR-TEM uses both transmitted and scattered beams to create an interference image. It is a phase contrast image and can be as small as a unit cell of a crystal. You can see here, you can see HR-TEM image of carbon anions. So the scale you can see is 10 nanometers. So you can see less than 10 nanometers. So it is very high resolution technique. Next. So TEM and nanomaterials. Now, when we are talking of nanomaterials, then this is just a slide which I show to the students where our nanometer is. So if you look at the atomic radii, then helium is one of the smallest atom, 0.49 angstrom to 3.34 for cesium. CC bond length is about 0.1 to 0.15 nm. DNA double helix is about 2 nm. Bacteria, small bacteria is about 200 nanometer, but mostly bacteria are in the micron range. Now here I am showing you the coronavirus, SARS-CoV-2. There is a lot of talk about it, so I thought let me show you. So here the size of the coronavirus is said to be typically in the range of 65 to 125 nanometers. Now, how these corona, this is just a picture, a diagram, but how you see, the scientists have been able to isolate this coronavirus from other viruses using transmission electron microscopy images, which you can see on the right. These are the coronavirus electron microscopy negative stain virus particle images. So transmission electron microscopy has very, very useful technique. Look, so now I'm coming to a very important group of techniques called scanning probe microscopy. Now, scanning probe microscopy is basically of two kinds if you look at the history. So, the first one was scanning tunneling microscopy, STM, which was developed in 1982 and by the team of scientists from Switzerland and IBM. Then Binning, Rohrer, and they also won a Nobel Prize in Physics for this invention in 1986. Then came atomic force microscopy, which was developed in 1986 by Binning and as a collaboration between IBM and Stanford University. So these are two very important developments which has helped us do research in nano. Because without instrumentation techniques, nobody can do any research on nanotechnology, right? So these are two very, very important developments. Now, what is scanning probe microscopy? Scanning probe microscopy consists of a family of microscopic forms where I'm just going to tell you where a sharp probe is scanned across a surface and some probe sample, and what it measures is the sample interaction or interactions if they are modified because of the modification in the sample. The true primary forms are scanning microscopy or atomic force microscopy, and there are three modes of AFM which I'm going to discuss. Next. So this is a scanning probe microscope. So, in this there are AFM, where you can have AFM of three different types. Then you can have magnetic force microscope, electric force microscope, surface potential. It depends on what is the sample if you are looking. If you're looking at magnetic properties which are differentiating, or electrical properties which are differentiating, or it is the change in surface potential, then you can use these different techniques. Then there are also lateral force microscopy techniques and electrochemical microscopic techniques. So this is a family of techniques, and anybody who wants to do the research will have to choose depending on the application. Next. So if you look at the scanning tunneling microscopy, so here I am showing you the picture. On the left hand side, you can see there is a sample, the blue one. Then there is a probe, and probe has a tip, that red tip, which is almost coming in contact with the sample. Now, what is happening is the probe has certain kinds of atoms and the sample has certain kind of atoms. Sample has blue atoms and the tip has got red atoms. Now, when the probe is brought near to the sample, what kind of interactions happen between atoms of the tip and atoms of the sample? That is being recorded. So, it also controls the topography of the sample, and that small tunneling current which is generated is picked up and amplified and then recorded. So this is on the right, you can see a highly oriented graphite sheet under STM. You can see very clearly, how the graphitic sheets have been arranged in a very oriented fashion. So STM measures the topography of the surface electron states using a tunneling current, which is dependent on the separation between the probe tip and the conductive sample surface. So this is the basics of scanning tunneling microscopy. So applications of STM are atomic resolution imaging. You can do, I think mostly physics people do. Atomic scale defects also you can find out. Then you have STM and all those. Poorly conductive samples also can be done here, unlike SEM and TEM. Then there are different force microscopy, magnetic force microscopy, where magnetic force gradient distribution above the sample surface is measured. Electric force microscopy, which measures electric field gradient distribution above the sample surfaces. Surface potential microscopy, which measures the difference in local surface potential across the sample surface. So it depends on your application, what is the material properties. Now this is one example of a picture. Now here electric and magnetic force microscopy have been used. So on the left, there is this sample, topography of the sample, and from there one area has been picked up, and on the right you can see the magnetic force gradient image of a metal evaporated tape at 100 nanometer lift height. So this is the measurement of a magnetic property. The materials which are there on the sample must be having a magnetic property. So using that magnetic property, the topography of the sample can be seen. Then there is a lateral force microscopy, which measures frictional forces between the probe tip and the sample surface. So there is a lift mode, and then there is a force modulation. The force modulation measures the relative elasticity and stiffness of the surface features, and force modulation is only one of the several types of force imaging techniques which are possible. Next. So here you can see there are two images. So phase and frictional properties have been used. So determination of two phases by deflection of amplitude due to van der Waals forces or frictional amplitude. And the inhomogeneity of the sample, for micro or nano composites can be, seen using these images. As you can see in this, wherever there are discontinuities in this, then you can see those defects. So this is using force, phase, and frictional amplitude. Now here is also measurement of tackiness. So see, you can see three columns on the right. So there is a tip, cantilever tip, which is coming on the surface. So one is that the tip is coming toward the surface. Now at point 2 in the second column, the tip has touched the surface, okay, and now it is interacting with the surface. Okay, so then how it is interacting, what is the material properties, how much adhesion it has with the sample, everything it can see, and then it retracts. So the attractive and retractive forces are measured, and that can give you an idea about the tackiness or adhesiveness of a sample. Next slide. So here you can see, if you have a large adhesion, then you will see the attraction and retraction diagram, something like this. If you have a small adhesion, then you will see right, like on the right side the picture. If you have a hard sample, then something like this will be seen. If you have a softer sample, then your attraction and retraction will be something like this. And if you have long range repulsion, it will be like this. And if you have long range interaction, so these are force curve examples, and it gives you an idea about the image of the nature of the surface. So this is electron force microscopy. Here again, you have a cantilever. On the cantilever, a laser beam is focused, and then this tip is moved, scanned along the surface. So as the tip is moving up and down, and what kind of forces it is interacting, the laser beam, will also reflect back in the same way, and it is caught by the photo detector, and that's how the image is formed. So the forces between the tip atoms and the surface atoms is something which is governing the movement of the tip, and that is detected by, because on the tip the laser beam is falling, and that is as it is moving, there will be a change in the laser reflect light, and
Ma'am, your voice is not, you are not audible now, ma'am. Ma'am, you are not audible.
Am I not audible now?
Yeah. Now you are
Yeah,
audible.
actually
Please.
I'm waiting for the next screen.
Yeah, but there is some network problem. Wait, ma'am.
Okay.
Yeah.
So, I am now going to talk about what are the three ways. They are different types of AFM. So there is a contact AFM, then there is a tapping mode, then there is a non-contact mode, and then there is a phase imaging technique. So if you have the contact AFM, then it measures the topography by sliding the probe tip across the sample surface. So it is in contact with the surface. Then you have a non-contact mode where it measures the topography by sensing van der Waals forces, which are attractive forces between the surface and the probe tip held above the surface. Please hold on to the previous slide.
Dr. Ashish.
Yeah. So in the tapping mode, instead of a continuous contact, you have a tapping. So what you do is measures topography by tapping the surface with an oscillating tip. The tip is oscillating. That means it keeps going up and down, and this eliminates shear forces which can damage. So if your sample is very soft, or it can get distorted, and it can reduce the image resolution, then you use a tapping mode. Otherwise, if your material is strong and hard, you can use a contact mode. And then there is a non-contact mode where you don't touch the sample, the tip doesn't touch the sample, but it measures the topography just by sensing the attractive forces between the surface and the probe tip held above the surface. Then you have a phase imaging technique where it provides image contrast caused by differences in surface adhesion and viscoelasticity. So these are very, very useful techniques. Actually, one has to be, if you have to use these techniques, you have to really go into depth of it to understand and how this technique can be useful for your research problem. It all depends on how much understanding of the technique you have. So that is, if there are students in this group, then I will say that, like, if you are given a car, it depends on you where you want to take your car. It is something like that. Next slide. So in atomic force microscopy, generally in the contact mode, you are looking at the height, the roughness, the friction and force displacement. And in the tapping mode, you are looking at height, force displacement and phases. And in the non-contact mode also, you are looking at the same thing, but you are looking in the form of, you are using soft samples, and you are mostly looking at the forces of attraction, which are acting between the tip and the sample. Next slide. So the contact mode, the advantages are high scan speeds, throughput is possible. Contact mode AFM is the only FM technique which can obtain atomic resolution images. Rough samples with extreme changes in vertical topography can sometimes be scanned more easily in contact mode. So disadvantage are that the lateral shear forces can distort the features in the image. The forces normal to the tip sample interaction can be high in air due to capillary forces from the absorbed fluid layer on the sample surface. Then the combination of lateral forces and high normal forces can result in reduced spatial resolution and may damage the soft samples, especially biological samples or soft polymers or silicon. So these are the advantages and disadvantages of the contact mode. Next. So in the tapping mode, the advantages that you are having high lateral resolution on most samples, lower forces and less damage to the soft sample, and lateral forces are virtually eliminated. So there is no scrapping. Disadvantage is it is slightly slower scan speed than the contact mode AFM. So next slide. In non-contact modes, no force is exerted on the sample surface because it never comes in touch. Never comes in touch with the surface. But the disadvantages are that lower lateral resolution, limited by the tip sample separation, slower scan speed. Then non-contact usually only works on extremely hydrophobic samples where the absorbed fluid layer is at the minimum. And if the fluid layer is too thick, the tip becomes trapped in the absorbed fluid layer, causing unstable feedback and scrapping of the sample. So there are problems and advantage and disadvantage of all the three modes. Next. So here I am showing you the AFM images, how we can use AFM to do our characterization of samples. So on the top, you can see the AFM images of nanofibers, and this is just the nanofibers, and here you can see nanofibers laid on non-woven. So the bigger diameter fibers are the micron size non-woven on which nanofibers have been deposited. So AFM can be used, although SEM seems to be a much better techniques, but AFM can also be used. In the below figure, these are the 3D view images of non-contact mode AFM images. Now, what we have done is, we have taken a PET fabric, a PET textile surface, and we have given it a plasma treatment. Plasma treatment, as you know, it causes some kind of itching because of the interaction of the plasma ions and charged ions with the surfaces, atoms and molecules present on the surfaces of the samples. So you can see the first figure with the unplasma treated sample is very smooth, okay, and then you are coming to the 60-second plasma treated sample and 120-second plasma treated sample. So you can see, as you are doing the plasma treatment, the sample is becoming from smooth to rough, because it has been aged, and because of aging, some kind of carboxyl or hydroxyl groups will also be present, that also can be seen, but at least the roughness has gone high. And in 120-second treated plasma sample, the roughness, you can measure the roughness also. There is a roughness parameter which you can measure on AFM, and this can give an idea about how much change in the sample topography is there with the AFM. Next slide. So nanomaterials characterization by spectroscopic Raman ultraviolet. This is my last section, so I'm just quickly going to cover on that. Next. So Raman spectroscopy, I think all of you know. You are all chemists. So I'll just give a very quick thing. Whenever monochromatic radiation is incident upon a sample, then this light will interact with the sample in some fashion. It may be reflected, absorbed, or scattered in some manner. And it is the scattering of the radiation that occurs which gives information about the molecular structure. This all you know. Raman is based on scattering. The sample is irradiated with a coherent source, typically a laser, and most of the radiation is elastically scattered, which is Rayleigh scattering. But a small portion is inelastically scattered, which is known as the Raman scatter, composed of Stokes and anti-Stokes portion. And this later portion is what we particularly interested in because it contains information in which we are interested. So I think you can see here, Rayleigh scattering is, so let us go to the next slide. Inelastic scattering or Raman scattering of monochromatic laser light impinges upon a molecule and interacts with the electron cloud of the bonds of that molecule, and incident photon excites one of the electrons into a virtual state. For the spontaneous Raman effect, Stokes Raman scattering, the molecule which will be excited from the ground state to a virtual energy state and relax into a vibrational state creates the Stokes Raman scattering. On the other hand, if a molecule is already in an elevated vibrational state, then it is called the anti-Stokes Raman scattering. And for Raman scattering to show a molecular polarizability is very, very important. And the amount of polarizability change will determine the Raman scattering. And that information is important to get the information, the changes you have made in the sample or something like this. So you are basically looking at Stokes Raman and anti-Stokes Raman scattering. And because of the change in the sample, there will be shift in Stokes and anti-Stokes Raman frequencies. And that gives you information about the change in the sample chemistry. So as you know, C.V. Raman, our Indian scientist, we feel very proud that this Raman spectroscopy was invented by him and it is named after him. This is a very proud thing for Indian scientists. I think many more should come. So applications of Raman spectroscopy are that specific bond information of molecules is possible. Then there are some Raman active fibers, and so carbon nanomaterials are found to be Raman active. So suppose in this fiber you have used these are multi-wall CNT, and see the multi-wall CNT samples on these aramid or carbon fiber have been shown, and strain has been applied onto the composite, and the change in the Raman peak with the change in the strain. Suppose you are applying this CNT nanomaterial onto a fiber and then you are straining it. When you are straining it, the interactions of carbon nanotubes or whatever you have imparted will change. And so there will be a change in the Raman peak. And this can give you an information about whatever you are looking at. Maybe it will lead to a change in the conductivity of the sample or anything else. Yeah. So Raman active materials, like especially the carbon nanomaterials, Raman spectroscopy is very, very popular. Even the graphene is now a very much talked about material. Graphene defects can be looked at by the Raman spectroscopy. Now you have our humble ultraviolet visible spectroscopy technique, which we use in our chemistry lab to look at the colors, chemistry and other things. So it is very, very useful technique because silver, gold and other nanoparticles which show surface plasmon resonance in the color, and the color changes with the size and shape. So you can measure that the dispersion of nanoparticles on a UV spectra, and you can look at where the lambda max is happening. So if, as you can see in this diagram, different shapes of the silver nanoparticles are absorbing at different wavelength. That means they will show different colors. Next. So these silver and gold nanoparticles have different colors depending on size and shape, and this is because of a phenomena called surface plasmon resonance. And this you can see if you start preparing nanoparticles of silver in the lab of different sizes and shapes, and you see different colors, then you can run an UV visible spectra and you can see, why this is giving a yellow color or why this is giving a green color. Yeah. Next. So then wide angle X-ray diffraction and XPS. These are again two more technologies which are used. Next slide. So if you look at here, this is an use of for wide angle X-ray diffraction. Structure of now here what we are doing, we have mixed polymer with a clay. Now clay is a high material compared to polymer, and we are putting the clay in the polymer. The clay is supposed to disperse, exfoliate. So if you run an X-ray, and it is still formed in the present for stacks, then you can see a very clear space. Put it in the polymer and see a very small peak because you have added very little amount. But if you see a very distinct peak, that means your clay has got dispersed in the polymer only. If your peak, is as a sharp peak, but it comes as a very low or a shifted peak, then you can see either it has intercalated, that means the distance between the clay platelets has increased, or if the peak is totally distorted, then that means the clay has totally exfoliated into the sample. And XRD is a very, very important tool for us who do research in polymer, clay, or any kind of nano composites to look at the distribution or dispersion of the nanomaterials into the polymer. Next. So XPS is a technique which a quantitative spectroscopic surface chemical analysis technique, and it helps to estimate the elemental composition, chemical state and electronic state of elements on the surface up to 10 nm. on a material. So here again you have the focus beam of X-rays, and then the electrons are ejecting out. These are the X-rays which are ejecting out, and the energy of the X-rays which are ejected out depends on what is the material there. So the binding energy, so that is caught, and then you get an X-ray. So this technique, I'm not going into detail now because time is short, but basically the interaction of the X-rays with the sample and the ejection of the X-rays depends on the nature of the sample. Next. So the theory of XPS is that based on again the photoelectric effect, emitted X-rays on the machine are focused towards the sample, and the X-rays have sufficient energy to ionize the core electrons, so that is the binding energy, and give them excess kinetic energy. So H nu is the energy which you are giving, and binding energy is the energy which is required to ionize the core electrons. And if you have given more energy, then that those electrons will have a kinetic energy. So Ke is the response which H nu provided from the machine, and B can be determined. So identification of elements are possible as binding energies for core electrons are unique for every element. Yeah, so this is the basic principle of XPS. So here again, I'm trying to show you the same, how it is happening. Ground state, and then the excited state, and then the photo emitted, how this is. So whatever releasing and the photodiode is collecting, you can see the XPS spectrum for all the elements which are present in the. So in this you can see fluorine, oxygen, nitrogen, chlorine, and silicon, and you can even calculate the atomic percentages, and these are the different binding energies for the different elements, as you can see. So you can see there's so many different peaks there. Next. This is electron spectroscopy. It can actually states. It can help quantify, as I showed you, surface specific. So satellite depth is only 10 nanometers. So only a depth of 10 nanometers is seen by that the X-rays can penetrate only that much depth, and it also gives you a surface imaging technique. Next. So this is now the actual samples of uniformity. So you have untreated sample, you can see the fabric, they have treated with some antibacterial coating. So that the middle one has been badly treated. This is an XPS image. So you can see the image, it is not very uniformly coated. And on the extreme right, you can see image where the sample has been uniformly coated. Now this has been possible because of looking at the XPS images of the material. Because whatever element has been coated, so the peak for that, how it is coming on from the different portions of the sample, is showing you the uniformity of distribution of that coated sample. So you can see it is badly treated, uniformly treated as compared to the untreated sample. Okay, so this is the. Now I'm coming to the last technique, that whenever you synthesize nanoparticles in the lab, then you need to measure its size and particle size distribution. So dynamic light scattering is a technique which is very widely used. Now the principle of this technique is that you have a laser light, you have a cuvette in which you put the dispersion of the samples. When the light falls, now there is a Brownian motion. These particles are not static, they are continuously moving. There is a Brownian motion. So when this laser light is going through the sample cuvette, then because of the movement of the particles, the light is getting scattered, and that is collected on the detector. Now the movement of the particles depends on its size. The bigger particles will move slowly, smaller particles will move fast, and accordingly, you can see the impression on the detector. And it basically uses a Stokes-Einstein relationship where K is the Boltzmann constant, T is the temperature in kelvins, and eta is the solvent viscosity. So you have to take care of, you can't use very highly concentrated samples also here. Otherwise, there will be movement will be becoming difficult. And D is the diffusion constant. So D is measured by the movement. Bigger particles move slowly and smaller particles move fast. This also not only the size but size distribution. As you can see here, on the y-axis is the intensity percentage and on the x-axis is the size in nanometer. So you can see this sample has a particular size, TiO2 nanoparticles. This peak, so you can see that maximum particles are of one size and there is a little particle size distribution. So the enhanced property is dependent on the size of the applied nanoparticles. So obviously there is some kind of an agglomeration. If agglomeration is there, then you will get 2-3 peaks. But so whenever you are putting the sample on DLS, you have to see that your dispersion is very nice, uniformly distributed, and there are no agglomerations in the sample. Next. So this is you can see some of them have a very sharp nano particle distribution, very narrow, and some of them have very wide. Next. So now concluding my talk, I'll say that current R&D trends in polymers and textiles clearly indicates a shift to nanomaterials as a tool to improve properties and get multifunctionality. And as you have seen, new and new products are coming. And as I have given you the example of 2 products that we have taken from the lab to the commercial scale. There are many products in the market now, of course, where they are using nanomaterials. Characterization techniques needed to study dispersion, impregnation, immobilization of nanoparticles on textile surfaces. I've already explained you with the help of examples. One of the major problems we face in textile samples is that textile samples are uneven because they are woven or non-woven. So sometimes, even in AFM or, many times we face challenges with handling the textile samples, and it is easier to handle textile films which are more uniform. Those kind of problems are there. So textile people have to work harder to get results from these techniques. Progress in sophisticated characterization techniques. I think in last 20 years, I've seen so much of, developments, very fast developments in the characterization techniques. When I started my research, we hardly had any equipment in the IIT. But in last 20 years, IIT has procured so many equipments, and now there is a very good facility for research. So now the students who are coming, they are lucky that all the characterization techniques, the tools are present in IIT for their research. And one of the underlining statement which I'll make is that whatever characterization techniques are there, but unless you have an expertise and understanding of the technique, which is the most crucial, utilize the technique for your research and understanding. So with these words, I'll conclude my talk, and thank you all of you for my patient hearing and some little problems here and there, the technical issues. Thank you. Next slide.
Thank you so much.
Next slide, you can show my group.
Prasis.
Yeah. So this is the, I have to thank all my students. Some of them you can see here. They are the people actually who work in the lab and get results for us. And in the process, they are learning. So I want to thank all my team, even people like Shiv. You know, he was in IIT, he was helping the students make samples, run the equipments. So people in the laboratory, you know, who are helping the students, they are also very key components. You know, because direct handling of students, these people are doing, and students are new; they do not know sometimes in their they can even harm the instrument, and then these people have to be very strict about it. So, thank you so much, Shiv. Thank you, all of you, for your patient hearing.
Yeah, ma'am. Thank you so much, ma'am. Thanks a lot for giving so much time in your presentation. Now, due to some network problem, Professor Ajay Taneja, our Dr. Bhimrao University, Agra is not available now. So I would like to requesting Dr. Sujan Varghese, head of the Department of Chemistry, St. John's College, Agra, Dr. Bhimrao Ambedkar University, Agra. Please, ma'am, are you available? So please summarize the talk, please. Unmute yourself, ma'am. Unmute yourself. Yeah, ma'am.
Am I audible?
Yeah, you're audible, ma'am. Please.
Thank you very much, Professor Mangala Joshi ma'am, for giving a very enlightening talk on various recent analytical technique as well as spectroscopic tools like SEMTEM, HRTM, SPM, MFM, EFM, LFM, AFM, and apart from that, Raman spectroscopy, UV visible, and wide angle X-ray technique. Above all, I'm very happy to know about your work. The advantage of other techniques and bringing through this, taking the examples of biocomposites and how you and your team has enriched biocomposites and made them high performance biocomposite fibers and enhancing the strength and all the physical chemical characteristics and enlightening our delegates. Thank you once again. And over to Dr. Shiv.
Ma'am. Thank you so much. Thanks a lot for summarizing very quickly due to some time issue. So, my special thanks to our Mangala Joshi, ma'am. Please, I'm always thankful to you, ma'am. Thank you so much for giving a very nice talk. Please. So now we are moving please for our next talk. For next talk, there is a chairperson, Dr. Rajiv Srivastava. Professor Rajiv Srivastava serves as an associate professor in the Department of Textile and Fiber Technology, Delhi. He has done his technical lesson in the poly technology from Royal Institute of Technology, KTH, Stockholm, Sweden, 2005. Master of Technology in Polymer Science and Engineering from Indian Institute of Technology, India, December 1998, and Master of Science in Chemistry from Indian Institute of Technology, Delhi in 1997. He has completed a PhD from KTH, Stockholm, Sweden in 2007. His previous experience include working as assistant professor at Indian Institute of Technology, Delhi from 2010 to 2016, teaching research and development administration. Program Master at Procter and Gamble from the 2008 to 2010, Business and the Technology Development. Senior Engineer at the Dow Chemicals from August 2007 to June 2008, Research and Development. Polymer Engineering at General Electric from November 2002 to August 2003, Research and Development part. Research Associate at Dabur Research Foundation from November 1999 to October 2000. Research and Development. Project Scientist at Indian Institute of Technology, Delhi from January 1999 to September 1999, Research and Development part. His research and interests are in polymer chemistry, biodegradable polymers and catalysis, emulsions and suspensions, polymer structure and property, relationship, and fiber science and technology. So list is achievement is so long that cannot be covered in this limited time. So now I would like to request Dr. Rajiv Srivastava to presents for the technical session. Thank you so much, sir. So now next year person of that technical session as Dr. Sujan Burgess. Sujan Burgess is presently working the professor and head in the Department of Chemistry and a coordinator of IUPAC Department of Chemistry, St. George College, Agra. Affiliated to Dr. Bhimrao Ambedkar University, Agra. She has total teaching experience of 27 years in 5 months in PG and UG classes. She has 58 research publications in the reputed peer review and national and international journals, and also presented his research work in the various national and international conferences, including SARC and National Geographical Channel. She was a coordinator for Analytical Instrumentation Training course, that is AITC, provides hands-on training on sophisticated instruments like AAS, HPLC, FTIR, UVVIS, etc. And resource person for AAS in 2006, and he was also the resource person for sophisticated biological skills science since 2012 in St. John's College, Agra. She has successfully completed 3 research projects. She has supervised 10 PhD degree. She is life member of Indian Council of Chemists and fellow research society at Chemical Science India. She is a reviewer of many journals. She is recipient of Excellence in Research and Teaching Award, Mahatma Gandhi Excellence Award. She was coordinator at BSc Industrial Chemistry and Counselor of Chemistry in Indian Indira Gandhi Open University. She was the convener of international conferences and recent advances in environmental protector 2019. Secretary for International Conference on the recent advances in environmental protection in 2009 and REAP in 2018. She is Assistant Director of Bharati Bhasha Kendra, Uttar Pradesh Government. And 13 lectures and sustainable development has been organized in international webinar in 2020. Department of Chemistry, St. John's College, Agra. She was organizing secretary for National Workshop on Indoor Air Quality Monitoring. And she has also organized the faculty development program recently and development of careers in higher education in 21st century in association with GAD TLC New Delhi under the PMMNNET. She was also the convener of National Webinar on Chemistry Education in 21st Century in association with GAD TLC New Delhi, India. So I welcome you, ma'am, and request you to take a seat for this session as a chairperson. Now I would like to request our keynote speaker, Dr. Menika Jha, is a scientist at Institute of Nanoscience and Technology since 2015. She has completed her master degree from University of Delhi and PhD from IIT Delhi in the field of chemistry. Prior to join INST Mohali, she was worked as the postdoctoral associate in the University of Louisiana, USA. She is working in the field of chemistry, material science, and their energy-related applications. She is also involved in designing chemical methods and extraction of nanoproduct from waste and wastewater treatment. She has 48 publications, 2 book chapters, and inventors at 5 patents. She has been awarded 2000 CRSI Young Scientist Award for her contribution in the field of chemistry, Index 13, etc. Now I welcome you, ma'am, and felt highly privileged to have you as one of our keynote speaker. I request you take this platform and over to you, ma'am. Welcome you, ma'am, and you can deliver your talk, please. Man, come in, please.
Dr. Siv, am I audible or?
Yeah, you are audible, exactly audible, ma'am. You are audible. Yeah.
Okay. And my slides are actually
Yeah.
not.
Yeah. Your content is also on screen now. You can continue, ma'am. And little bit fast, ma'am. I'm requesting you little bit fast because due to the time issue, please. Okay, ma'am. Thank you. Continue, please.
First of all, I would like to thank you and Dr. Assis for organizing such a wonderful meeting. And because Dr. Joshi has already covered most of the thing, and I am working in the area of nanoscience and nanotechnology, so I will be just focusing on the application part. So I'm going to talk today about analytical method for detection of waste composition. This is one of my main area. Basically, I am working in the field of chemistry, but one of my area is societal issue addressing in NST. So I would like to share some of my results in that particular direction. So the screen is yes. So basically, I would like to focus on the science of measurement. So it's very old technique. We started way back, and going through lot of literature. What I found, there are two basic approach in science of measurement. One is a targeted approach, other is a basic research. So basic research mainly it has been ignored these days because of modernization, but I feel that is also one of the important part because that create lot of innovations and new. So I will be discussing some of the part of my research in terms of basic research, and other is targeted research. That targeted research basically address some of the issues which our society and industry everybody is facing. And both the technique needs characterization and their application. So this is what I am going to talk today. So basically, most of the nano-based characterization Dr. Joshi has already covered very nicely. So I will just point it out. Uh, Basically, for any characterization, we need the analytical methods and their application specialists are two main things. Big main thing which help any scientist for their research. So if we have a good instrument, so we need a good technical skill to extract data from the instrument. So that is also equally important. So for this analytical method, the first of all, what we need to preliminary think is problem. What kind of problem we are going to address, and for that particular problem, we should have a proper expertise and simultaneously that to meet both the one and two, we need to have certainly this equipment and a good technical skill. So basically, for any kind of analysis, this problem definition, first of all, we should know all the prior arts and benchmarks. Then we can do all other things. And once we know the prior art, then we can develop using our certain innovative technique, different method to solve that. As Dr. Joshi already showed, she has come up with two products by using all these skills somewhere, some. So basically, to address any problem, we need to know what is our sample size. So normally we work on, as a scientist, we work on 4 different sample size like meso, semi-micro, micro and ultra-micro. In most of the advanced technique, because we don't want to use much sample, so we work in the micro and ultra-micro. But normally, meso and semi-meso scale sample size is a routine analysis technique, and these are the different methodology which we normally use to address any kind of problem, either inorganic, organic material. I'm not going into detail because Dr. Joshi has already covered most of them. So just I try to summarize, and I think Dr. Joshi has very nicely already covered. So these are the 5 techniques which I normally use to characterize my all waste which I use for my research. So basically chromatography, thermal gravimetric analysis and differential scanning calorimetry, diffraction technique, X-ray, small angle and neutron diffraction technique we use. Microscopy, light microscopy, electron microscopy, atomic force microscopy, scanning tunnel microscopy we normally use, as Dr. Joshi already mentioned. And most important thing, spectroscopy is one of the important tools for characterization of any material, whether it is nano or bulk material. So basically, what is the role of analytical chemistry in modern science? That I am going to address, and how I have taken inspiration from the background research. So basically, what I found, the waste which creates either domestic waste, industrial waste, and any kind of waste we create, we normally try to recycle. So with that recycling technique and conversion of one-way material to waste material, already our earlier artists have shown, because they are very futuristic in nature. So suppose if you have a waste cloth or textile material, you can go into the market and you can see, you can get door mats, you can get bags, you can get several handcrafts. Also, with the waste material, you can create lot of creation for the garden. This is not related to nano, but this we normally see, but might have been ignored. So basically, one thing which I would like to share, because I am located in Punjab area near to Chandigarh. So this is a story which was created by Mr. Nekchand Sani. He was a government official, and he used construction site waste to create a huge garden. And this is now a tourist place in the Chandigarh. Specifically, this is a big demonstration for the waste utilization. Interesting thing, when he started, it was normally it was told that the whole work was illegal according to administrative point of view, and because he wanted to grow a garden out of these construction waste, so what he tried to do, he hided this work for next 18 years, and then somehow with the help of, he just tried to keep it up with the local support, and now it is called a rock garden that is located in several acres, and till now, from its inception, more than 12 million visitors we have, and it is one of the financial source. So you can imagine this Mr. Sani was not a scientist, he was just a simple person. He just looked at the construction waste side waste, and he tried to create a simple garden which anybody can do, but with the constant effort he has created a tourist place to us. So that is, I think, one of the big things. So my approach is the waste which we are looking at around us. I will, because a lot of people from Delhi, so I will like to share some of the data which I picked out from past few years. So these are the different places you can see in Delhi, and where we have this, waste piled up. It's the kind of landfill which is near about close to our Kutub Minar monument. So this is quite embarrassing. I am also from Delhi, and I used to see that thing, and it was not very good. However, recently people have more educated or they are more concerned about environment. So what they have created, a group of scientists have tried to convert um, this height in the Okla area to the green area. It's called Eco Park. I think most of us might have visited. This is one of the examples. So how this scientific thing input we can give it to waste. So I am trying to give some glimpse about some of my research, which is in the direction of pollution control. So what I am going to talk about is how I have used analytical technique to address pollution composition and how I have utilized this information to make. So I will be focusing on air, water, and land. So basically, when we talk about pollution, so what is the first we need to understand the origin of pollution before addressing it, because we are constantly polluting our environment. So how smartly we can work and so that we can have a sustainable life. So basically, when we see the pollution, there are two types of pollutants. One is visible pollutant, and another is hidden pollutant. So visible pollutant, you can see mines, forests. Those you can go and see how much pollution is around. Automobiles also, we can regularly see how much pollution automobiles create. So now the era of electric vehicle is going to come soon, and the power plants. So these are the thing which is a visible pollutant. We blame them, but we cannot stop them because we are economically dependent on them. Second thing, it's not only mines, automobile industry, and power plant is polluting. We are, as a domestic user, we are also creating waste, and it has been tentatively estimated that almost 10 kg of waste per day every household is generating. Our local market and farmers are also generating lot of waste, and which is not getting addressed by anyone. So basically, overall picture, if you can see the pollution stuff, there are two types of pollution: then visible polluted and hidden polluted. So and they are basically polluting our air, our water bodies, and our. So basically, more or less, when we look at the news in the media, so what we tell, industry are the most polluters, and we put all the government norms to get a clean, get the pollutants clean. So basically, there are two approach normally. What I have seen in last my career, government are trying to make us self-independent. So for that, there are lot of scheme they are generating. And parallelly, in the another word, they are putting lot of pollution control restrictions. So these two are contradictory approaches. What I feel. So normally, what happens, like when we look at the industry, we cannot stop industry because we are economically dependent on it, but we cannot pollute our environment. So can we have a sustainable proper suitable management skill over here? So that is what my group is trying to look at. So I will just tell you about how polluted this data is for how much our domestic pollutants is there. So you can see Delhi is on the Gujarat, Ahmedabad is on the top number in the pollution scale. So basically, the pollution treatment, how we can do, we dump our waste in the landfill, Sometimes we do incineration, which creates lot of environmental issues, air pollution. And sometimes we also do the compaction to make roads. So that is also not very sustainable. Also, we do have a very defined norms for all kind of waste management. But basically, I went through all and I found the electronic waste management is a little bit ignored. So the special policy needs to be there. So basically, what is happening? What is issue? Basic issue is lack of awareness to our people. We are mixing all the junk in one basket. It has been there has been a survey, and I hope most of you may agree. In most of our houses, we have only one basket in which we dump all our waste. So the waste segregation is one of the problems. And that is why people like to dump that waste in the as a landfill. So and that creates lot of land scarcity, and also we are basically low in the electronic waste management. So what is happening? So normally, if we can convert this waste to nano products, then we can generate lot of revenue out of this, and that can be source of the income. So then we will more concerned about this. So basically, this is a basic market survey of the particular thing. So what we are trying to do, we take our nanometer waste as a starting source, and we try to convert into the nanometer. So normally, we earlier what we used to do, we used to convert, recycle, or either we can make a small low cost material. So now if you can see, compare a simple silver cost, which is close where simple silver cost, their micron size cost and their nano size cost. So you can see we can have so the bulk cost what we are having here is quite lower than the nano. So here we have opportunity to grow. So what I will talk today, I will take three kinds of waste: domestic waste, e-waste, and industrial waste. I will show how I have utilized advanced technique to characterize this and how I try to convert into the nano. So basically, I will start because I will try right now. I am trying to address this hidden polluter, that is a domestic polluter. We can see this kitchen, and I know everybody has a clean kitchen, but this is a worst thing which you can imagine. So what in the kitchen, what kind of waste I have taken is tin cans, waste refined oil, waste food, waste battery, and waste paper. These five kind of waste I'm going to talk, how I use it, how I can convert it to the number. So I will start with tin can. So whenever you take some tin can, what we normally in the normal cases, what we do, we just throw away in some few rupees kilo. I think the maximum cost you will get for this tin can is 15 rupees per kilo. So what I tried, I took it and I tried to look at what is there using advanced technique. So as Joshi ma'am suggested just now, we can use EDAX to find out the composition of material. So what I did, I put this tin can under EDAX, and I found that it has a good quantity of tin, and so tin is in the large quantity. Then I tried to run X-ray on it, and I have seen it has a tin, iron, and tin oxide. And the surface you can see little bit of tin oxide and iron. What I did, I wanted a nano iron, which is nano iron sheet. Here I tried to make. So what I did, I just tried to etch the surface, because normally when we cut it and when we do the cross-sectional assessment, you will find around 2 micron thick layer of this tin which is coated onto iron surface, steel surface. So what I did, I tried to etch this thin layer and I tried to get a pure iron. So that pure iron, I tried to look at the surface. So I got a very rough surface, and then again I tried to look at their EDAX. So all that tin was removed. So I developed this protocol. This is simple acid etching protocol which I developed. What I did when I looked at closely, I saw very nice iron sheet were formed at the surface of iron. And iron is very good oxygen generator if you be apply little bit of potential. So what I tried to do here, I took this sheet, delaminate it, I created iron sheet on the this, and I tried to run one simple cyclic voltammetric study. So you can see at this position you can get quite a good amount of oxygen. So now if you look at the price which is in the market, oxygen cylinder, if you are going to buy, it will be close to 12,000 including cylinder. And refilling cost we need is close to 1,000 rupees. So if parallelly I took 1 kg of this, and that can generate 5 liter oxygen in 20 minutes. This is why, and we are still developing this technology to be developed. So, and that cost around 5 to 15. So the waste which we used to dump, that can be oxygen generator. So real oxygen generator fabrication is still going in. So next thing, because I want to make valuable material out of this waste, so again I took same material. What else I can do? So I looked at all the iron salt, and I found that the ferrous salt is very expensive. 25 gram you can get into close to 10,000. So what I did earlier, I have made a product. Earlier, I have made a product which was close to 1,000 rupees. Now I want to again add value to it. So what I did, I took this iron. I tried to create this FeCl2 water. This very nice crystal we got. So that crystal, scale up project is also going in our industry to make large scale production of FeCl. Next, what because I am also working in the water purification work, so what I try to use this iron chloride material to make goethite or other iron-based compounds for trapping of uranium and arsenic and various other organic pollutants. So basically, these are the characterization technique which really helped me to identify the type of material, what is its size, and all. So I will not go into detail. I will quickly show you the material which we got for arsenic. It can remove 93% of arsenic from water. You can imagine earlier we were dumping these tin cans into the landfill and which were creating lot of pollution. Now it is cleaning our water. So this is the way we try to address the problem. We are also we have used a photocatalyst that can be used because it's a low cost process. So this material can be used for cleaning of water in the large scale. So we made photocatalyst and it was working very nice in terms of photocatalyst. So I use X-ray, EDAX, theoretical method, transmission electron microscopy, all those methods to characterize this material. So basically, these tools are important because it gives me the exact quality. So these are the photocatalytic reactions. So I use UV visible and fluorescent study to identify the band gap of material, to identify how our dye is degrading, all those things. So basically, I took waste tin can. I tried to convert it. Use this waste tin can to generate oxygen, to make arsenic filter, and to make photocatalyst. So this is one of the domestic waste. Second domestic waste which I have taken is waste cooking oil. I think in most of our household, when we it is FSSI recommendation, like we cannot use oil which is used 2 times. So when we use one oil for frying purpose more than 2 times, it's basically toxic and it has lot of health. So normally the used oil people have used to make biodiesel, but because of low adaptation as a biodiesel, the thing is still in. So what I try to use MMR, HPLC, mass, all the techniques. And what I found, the cooking oil are mainly composed of various fraction of fatty acid. And how I can improve the cost of this cooking oil. So what I tried, this is my previous experience. I used to make quantum dots during my postdoc period in the United States, where I used to buy a lot of expensive coordinating solvents to stabilize these materials. Similar kind of fatty acid and amine I used to buy. And I failed. When I tried to scale up, I faced this lot of economical issue. So what here in INST, I tried is this body waste oil can be used for stabilization of these kind of quantum dots. So, this is the initial experiment we run, and we can make a very nice red, blue, all sort of quantum dots. So now these quantum, because this is being made in normal refined oil, which is biocompatible, so this we can easily use for secret writing. Of course, I know cadmium selenide is an toxic material. So, what my group is trying to stabilize non-toxic material like indium phosphide and other phosphide material to make such quantum dot, and that we are going to use in the secret writing. So another thing, like we know in our home, we try to cook pakoda. So can we cook field emitters? Can we cook several complex chalcogenides? Yes, we can do. So I use same oil and I try to stabilize molybdenum oxide. Only at 200 degrees centigrade, very nice molybdenum oxide we can get, and that gives very good field. So the oil which we are going to through in our kitchen sink, that can be utilized to make this high-end material. So this is what I want to show here. Also, the chalcogenides are very important these days in terms of electronic material, which is a high-end material. So that can be synthesized at low temperature also. Both are synthesized at 200 degree just in boiling, just like you are cooking something in the oil. So both are done in the same manner. And you can see we can make supercapacitor, we can make field emitters in this kind of oil. And very good quality, better than the normal. So when we look at our kitchen dustbin, so sometimes we throw our batteries, which is a part of electronic waste in our dustbin, and the mostly we use AA battery in our small gadgets. So it is a basic survey which has been done, and it has been shown that AA battery is being used in the entire world, in the different countries. What is happening? What I took this waste and I just put into the water, and I just try to look at the pH. So more than hundreds of battery from different company I put into the water, and what I have found, the water pH will raise around more than 12, which is not good for our environment. So, this waste segregation, a lot of issue we face here, like we don't know where these batteries are. So, this is a basic thing. Normally, AA battery has a zinc which is getting converted into zinc oxide, and manganese which is getting converted into manganese oxide. and that way the electron transport gives us a suitable current to run our gadgets. So what we do, we just segregated our this battery, and we just segregated all anode and cathode. So basically, when you look at the battery, so we have anode material, we have anode collector, we have cellulose separator, we have cathode collector, we have cathode. So this is it is a very simple way we cut our battery, and then we have segregated each and every. What interestingly we have found, initially when we cut the battery using XRD and EDAX study, we found the composition of each component. Once we know the composition of each component, then only we can decide for what purpose we can use this. So similarly, uh, for example, I took anode comp. I will tell you first thing about anode comp. So basically, what is happening when we charge battery? This was not told earlier. So normally, basic chemistry was known for a long time, but microscopy study like ACM Joshi told has not been done on this battery when it runs in situ microscopy. So what we did here, we did in situ ACM study in which we try to run the battery for a certain period of time. And what we have found, the fresh battery is having a globular type of structure. And when battery run and its potential degrades, we can get a very nice nanorod. And which is, zinc oxide nanorod is one of the expensive material and which we are trying to throw in our garbage. So this has not been addressed earlier. So what we took this zinc oxide anode material. It is in situ synthesized. When you operate your battery, you will get your zinc oxide. You don't know all the anode. You get a very nice nanorods of zinc oxide. So we purified this nanorod, and we have used it to treat organic pollutants. Because zinc oxide is one of the material which has been pretty good in quantity used in the field of electronics, in the field of cosmetics, in the field of antibacterial and all these. So what we are having, so this solve this we what we took these zinc oxide and we have got very nice organic pollutant degradation. This we have monitored using UV visible spectroscopy. We have also tried to convert this into the field emitter. So what I do, I put on the silicon wafer and I try to run this measurement. So and which gives very nice result. So what we are doing, because zinc oxide nano ink is very important for antibacterial and antimicrobial properties. So we try to make a biocompatible zinc oxide nano ink using this material. And when we look at the waste battery cost, you buy a battery in 10 to 20 rupees, one AA battery, and you throw it away in the zero cost. One battery, you can see the cost of this zinc oxide, 5 ml zinc oxide ink, you will get close to 9,000. It may be more today. So yeah, so this kind of material we can use for making antimicrobial textile material. So these are the life cycle analysis of this thing. So now what I found, this is okay, this is a basic zinc oxide which was already formed in the battery when it operates. Can I may use this zinc oxide to make another exotic material? Because I'm a chemist, material scientist, I want to make an exotic material. So I want to stabilize complex oxide using this, using all the components. So what I try to make spinel compound, that is zinc manganese oxide listed in Mn2O4, and I clubbed with the carbon anode, which was thrown away. So what I did, I dismantled this. This is the battery part. I took this part. I extracted zinc oxide, extracted manganese chloride, and used this raw carbon raw density. And I tried to make zinc manganese oxide ZnMn2O4 spinel compound in the form of nanoparticles, and I tried to make this heterostructure. And both are doing very good in terms of their battery applications. So yes, here what we can, this is a case for lithium ion battery application. This I took help of C3 CSIR lab. So they use our material and they try to integrate secondary battery. So this is a case where I use waste primary battery material and converted into the secondary material, battery material. So the next waste I am going to talk about the paper, waste paper. I think in most of our offices we use waste paper. So what we do, we using our analytical skill, because normally we see this paper like this image you can see. But when we look at the XRD, we can see get the composition. And what we have found, this waste paper composed of cellulose along with the calcium oxide. Calcium oxide is normally used in fabrication of paper to increase its brightness. So basically, when we use this SEM study, as Professor Joshi has just now explained, this we can use for analysis of fibers and this. So here I use this SEM study to analyze this paper waste. So what I found, we have a very and simultaneously in this case, I try to map this using EDAX study. So in this case, this is a basically advanced technique, SEM mapping technique. I am doing mapping. Simultaneously, I am doing EDAX analysis so that I can try to find where is my calcium carbonate and where is my cellulose is there. So we can easily see our calcium is present like a spindle, and our this cellulose fiber is there. So what we found, if we burn this paper, because paper burning we might have learned from our very young age, we take paper, we burn it. But I was not throwing, we can extract very good material.
Sorry, ma'am, to interrupt you, please. Little bit fast. I'm requesting you, please, ma'am. Don't take it otherwise, please. I'm requesting you. Thank you. Thank you so much. Thank you so much.
So what I took, I used TM study to find out exact size, and we have gone and we have used this electrochemical analyzer to analyze CO2 content. I'm not going into detail of the techniques, but what we have used, we have burned the paper and we have selectively used this CO2 gas which was evolved to make this calcium carbonate. And that calcium carbonate we have used to convert into their oxide, and we have used for trapping fluoride. So I'm not going into detail of chemistry. This is how I used various techniques to achieve my work. We have also used the similar compound to trap lanthanide, and this is a demo model. This I have done in consultation with IIT Delhi Chemistry Department. We have made a very nice water filter out of this. We have used a similar kind of material to trap various organic pollutants, and this is our cartridge, which we are scale up is still going on. I think soon we will come up with some purifier, and this is our demo model for the utilization of cartridge. So scale up is still in progress. So our this work is in e-Samiksha. This is basically monitored by Prime Minister. Monthly monitoring we are going to do. So we update we submit to our Prime Minister. So I will quickly go through some of our industrial work which we have done. So here I collected some waste from industry, and this is which is located into the Himachal Pradesh. and we have analyzed this waste using pH, various spectroscopy techniques. And what we have found, we attempted to stabilize various products which can be used immediately, because industry is generating huge waste, and if we will make exotic product which do not have end user, then that will be a problem. So here, my all the work with the industry is we try to generate zero waste. So with this industry, ceramic industry, we have made a soda, because we know soda has a good utilization in soap industry, glass industry, everywhere you can use. So very nice soda we got. We have shown their utilization in textile industry. The similar kind of waste we have used, we have extracted sodium nitrate nanoparticle. We have characterized by XRD, SEM, TM, everything we have used, and we have converted into the heat storage material. So that is giving a good quality. So I will skip these things. What I will do, air pollution, as initially I mentioned, air pollution, we normally blame power plants are air polluted. So yes, somehow they contribute to our air pollution, and they generate huge quantity of carbon dioxide. So what I use this carbon dioxide to make soda, and I use this soda. I am planning to use this soda to make detergent. So this is our power plant demonstration in Dadri plant. The real trial we have completed last year, and there we have taken a real power plant effluent, and we have tried to convert into the nano. So you can see this was a live thing. You can see good amount of NOx, SOx, everything was there, and we have converted all of them into the suitable product, and we are getting a nice quality drinking water to. So another thing, this double burning, same CO2 I have used, and I have attempted to make soda. This technology I have basically dedicated to the villagers. I am working with the Punjab government to implement this in some of our Punjab villages. So I tagged with the two company. One is the soap industry, and another is a Tata Consulting Services. So when we burn this stubble, we get CO2 and we get some ash. So as we are utilizing to make a brick, so that if we can demonstrate this into the village, that brick can be utilized for the construction purpose. And this soda we are trying to make with the SRD industry Punjab, they are helping us in detergent formulation. So this way I try to tag with, I am working as a scientist in this, lot of industrialists, 2-3 engineers are there. So next thing we are working, this same as can be utilized for the lighting room. As I am inspired by artists, so this is a right side image. This is an image created by Dutch artists. They have created this lighting room. But what I try to do, I am right now working with Tata Consultancy, and there we are trying to make a lighting room so that this can be demonstrated in villages, and I think villager will not face issue of this light on the road if this project will be successful. So these are various demonstration we have done. So out of these low cost process, I am also trying to work with the high cost material, this Titan. The beautiful part of this is that this company told me to enhance their gold cost. So what we make, we took their gold and we try to make a nano gold, which is quite expensive. So this gold is also waste from their mine. So we have made a different colored nano gold, and we have made enamel. So what I try to do, I have used various kind of waste. I utilize this analytical technique. Without that, it was impossible to make products which can be locally used. Because if we will target very exotic product, then we will be in trouble in addressing the problem of waste management. So basically, I try to develop a solution for pollution. So basically, my target is waste to useful product. we can generate zero secondary waste. And I'm trying to integrate approach from government, policymaker, industrialists, and engineers. All four are working in most of my projects to demonstrate something. So basically, I'm trying to address environmental, energy, food waste. I'm trying to address, and if we can address all the waste issue, then hygiene will be automatically high. And this all if we can demonstrate this in the in the large scale, then certainly we will have a good sustainability. So I would like to thank all my postdocs and PhD students. Most of them are here. INST for funding, DST, INST and DST for funding, a lot of my industrial collaborators, as well as scientific collaborators. Thank you very much. Now I would like to take any questions.
Thank you so much, ma'am, for giving a very nice talk. I'm request Sujan Varghese, ma'am, please summarize the talk, please. Dr. Sujan Varghese, ma'am, please.
Yes. Is am I audible?
Yeah.
Okay. Thank you, Menaka Jha, for a wonderful and insightful talk on how to convert waste into a zero waste and convert all the waste into a product which is useful, and the waste which is found in your kitchen slab, which is found in your locality, convert into useful product. And being a chemist, ma'am, it is very encouraging for each one of us to be use these technologies and take techniques and analytical methods and from you, and why not we use this for each locality, and or people, the delegates represent from different parts of India, why not we carry this message of yours into our own locality, and with your help, why not we extend this collaboration. It was wonderful to have you with us, ma'am. Because of the lack of time, limitations are there, so I am not getting involved into this, but I am very happy to have you found a method for arsenic poison, which is a very localized problem even in Agra. So ma'am, thank you once again for elaborative and very nice talk, very useful, very down to earth products. The problem you have taken, especially you are working in Punjab, and stumble burning you have converted again into the useful product. Wonderful, ma'am. With that note, I would like to wind up this concluding section. Over to Dr. Shiv.
Thank you so much, ma'am. Thanks, very nicely concluded the session as a chairperson. I'm highly thankful to you, ma'am. Now, in the series of this, we will move for the next talk, which is given by keynote speaker, Dr. Bhupen Tiwari, sir. So for the session, chairpersons are Dr. B.D. Upadhyay has been working as a principal at Dharmjyoti Degree College, Aligarh, Uttar Pradesh. He has done his graduation, post-graduation in chemistry and doctor in philosophy from chemistry from Dr. Bhimrao Ambedkar University, Agra, Uttar Pradesh. He has contributed a lot in the field of research and development at national level, and having more than 25 years teaching experience in UG and PG level. He is a member of many professional organizations. He is life member of Asian Polymer Association. He has supervised PhD students. He has publications in both national and international journals. He is very dynamic, and personally he always worked hard for betterment of the education system. He is always very active, visionary, and enthusiastic, and has a firm belief in doing the things rather than saying it. I welcome you, sir, and request you to take the seat for the chairperson. So now our next chairperson for this session, Professor B.S. Butola from IIT Delhi, obtained his BTech degree in 1990 and PhD degree in 2005 in textile technology from IIT Delhi. After a brief stint in the industry, he joined the department as applied chemical sciences and technology textile chemistry stream Guru Nanak Dev University, Amritsar, Punjab in 1997 as a learner. As a lecturer, he obtained his PhD in the services, joined at the Department of Textile Technology, IIT Delhi in 2007 as assistant professor. At present, he is working as a professor in the same department where he has helped start the postgraduate programs in the textile chemical processing in 2017. His research interests include functionalization of textile with metal oxides, smart colorants, use of shear thickening and fluids in improving the impact performance of the ballistic textile and polymeric nanocomposite. He has published almost 75 papers in referred reputed journals and has edited 5 books also. So thank you so much, sir, and request you to take a seat for this session as a chairperson. I'm requesting you, sir. So for the keynote speaker for today's this talk, Dr. Bhupen Tiwari. Tiwari is an associate professor in the Division of Molecular Synthesis and Drug Discovery Center in Biomedical Research and SGPGIMS campus, Raebareli, Lucknow since 2017. He worked as an assistant professor, Center for Biomedical Research, Lucknow from 2014 to 2017. He also worked as scientist D, MACS Agner Research Institute, Pune from 2013 to 2014. Senior Research Associate, Sai Advertium Farm Limited, Hyderabad, and to the and postdoctoral fellow for Professor Bai Robin Chai Group, Niang Ting Technology University, Singapore, 2014 May and 2010 December 2013. He did his PhD in organic chemistry with Dr. S. Chandrasekhan, CSIR, IICT, Hyderabad in February 2009. He did his MSc and BSc from Tripura University. He is a postdoctoral research fellow nanoscience technology and University Singapore. His research interest lies in the area of nanoheterocyclic carbene catalysis, hyperlinked iodine catalyst, synthesis of bioanalytically active natural product, and medicinal chemistry. He has presented his work in the various national and international conferences. He has also published several research articles in the national and international journals. He is also the member of various national and international committees. So list is so long for your achievements, sir. I'm requesting you, sir, and welcome for deliver your talk. And if you can start, sir, I'm very thankful to you. Please, sir, you can start your talk, sir. Professor Bhupen Tiwari. Unmute yourself, sir. Unmute yourself.
जी हाँ बोलिए सर.
Yeah, you are audible, sir. You are audible. You can continue, sir, please.
Am I audible, sir?
Yeah, audible, sir. Audible.
Hello. Yes, sir. Yeah. So one more help I need in before I start that how to change the slide. So should I like because here I don't see the option of changing. So should I go to my
Dr. Ashish, help him. Dr. Ashish, help him. How you can move your slides?
Hello. Ashish, so I don't see the option here to like change my slide. So should I open my PowerPoint or I should be on this WebEx only?
आपके
I
साथ
think you
screen
can
share
move,
हुई है,
sir,
दिख
from
रही है
right and left keys.
But it's not
in your keyboard, from your keyboard, sir.
just I think ah, mouse on it. उसको फुल व्यू में कर दें, इसके बाद फुल व्यू कर दें। फुल व्यू करने के बाद से तो फिर वो स्लाइड मोड दिख रहा है, स्लाइड सेल दिख रहा है, स्लाइड सेल तो
There is no change in slide. There is only first slide.
ओके
आप ऑटो मोड पे ना लें इसको, स्लाइड शो में अगर आप वैसे ही दे सकते हैं तो ज्यादा अच्छा रहेगा सर।
So if I like, if I'm changing, here is it okay? If I am changing now, is it changing? No. Now, again,
Yes, sir. It is now movable. Yeah, sir. You can continue, sir. Yeah. You can continue, sir. In that way, you can continue, sir. Please.
that I do. So I'm audible, right? Audible. Right?
Yeah.
Thank you. So, sorry for the technical glitches. So,
No problem, sir. Please, you can continue.
thank you for your kind introduction and for the invitation also. Basically, I'm a bit odd man here if I'm right, because I'm a pure organic chemist or hardcore organic chemist, if I say that way. Even though we use a lot of analytical techniques, but basically we do
You can adjust your mic, sir, with the distance. So your voice is not clear coming. Yeah.
basically we are doing catalysis.
Yeah. Now it is clear, please.
So today the whole presentation I will summarize into this title that what we call it continuous selective functionalization of molecules using targets and target. So we are basically a catalysis group tool of CBMR, and we use two main class of catalysts like we call it electrocyclic carbines and alcohols. So these two modes of catalysis that we use for the development of new reactions, new methods. So these are a kind of tool for us that we use laboratory. And because the whole part will be somewhere related to catalysis only, so what I thought, because we have different kind of audience from graduate to masters. So why not to have a recap on catalysis? So we all know that it's just a kind of a recap only that for any kind of catalysis, whether it is a chiral catalysis or non-asymmetric catalysis. The cycle is same, at least combines with the substrate and it forms adduct in which the catalyst is chiral and we have chiral, then it undergoes transformations and in that either the substrate combined itself undergoes changes or it combines with other substrate. It combines with some other substrate to generate the product. Till the generation of product,
Respected sir, Professor Bhupen Tiwari, you are not audible now. Your voice is very less.
is it now audible? Hello.
Yeah.
Now is it audible?
Yeah, little bit improve.
I don't know why, but my end internet and everything, but somehow. Okay. So I'll try to. Whenever it is not audible, please feel free to.
Yeah. Please.
Um, that it's a kind of this slide is a kind of recap only on catalysis because we have audience from masters to graduate students, so I will mainly keeping in mind the students. So it's this cycle through how the catalyst works. So basically, chiral or a chiral catalysis. Have a catalyst or a molecule, it may be organic, it may be catalytic molecule that combines with substrate, which is a chiral. Then it forms a duct, which the catalyst is chiral, and we have a chiral substrate. So together, this duct is chiral. It undergoes changes or transformations. Then it is
Voice problems or continuous voice is not coming properly. नहीं वो ठीक है.
because we are in the, I'm in the office and we have a good internet, so but somehow I don't know. Is it okay now? Hello? 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 Hello?
Is there any issue, sir?
Actually, there I have checked with other sites. It's working. So,
Sorry, sir.
I mean, other sites are working fine for like I checked with the internet opening other sites, it is working. So,
You can continue your talk, please, sir. Yeah. It is visible your screen now. Yeah.
so I'll continue.
Now it is visible, sir. You can continue.
Okay. Okay. So, and then we come to this. So, this is the cycle that you know already from your masters and the business also.
थोड़ा सा आप तेज बोलें सर, क्योंकि माइक प्रॉब्लम कर रहा है. हल्का सा तेज बोलेंगे तो सही आ जाएगा. बस अपनी वॉइस को बढ़ा लीजिए, हल्का सा अपनी वॉइस को बस.
Then, so we know that the catalysis, how, I mean, the role of the catalyst and how it,
Yeah.
what it does with the reaction. So, and how it works. So, any class of catalyst, whether it's organometallic or organometallic catalyst, it facilitates the reaction by lowering the activation energy. That means it either lowers the hormone or it raises the lumen. You know, a very good example of hormone activation as well as a lumen activation. So this is a amine catalysis. We basically activate the nucleophile using a catalyst. The lumen activation basically activates the nucleophile using catalyst. So this is the overall concept of catalysis. Now at CBMR in our group, we are basically working through broad areas like functionalization of polyphenol double bond, and we have adopted two approaches for this, which we find a very complementary. Like the first approach is the carbon based, as well as a hypercolor. Why we have chosen these two different mode of catalysis? So basically using our carbon catalyst, we can take
Your voice is not coming, sir.
join it again, disconnect and join.
Very slow voice is coming, very slow.
Sir, you have to change your mic. जी earphone.
If it is possible, sir, you can change your mic if it is possible, right?
Hello. 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 Hello.
ना वो लैपटॉप रख रखा है.
Hello.
sorry for inconvenience. Please, he's trying to connect with another device, I think. So please stay tuned for 4 to 5 minutes. If he will join, otherwise we'll move next. All of you are requested to wait for 2-3 minutes, I think.
मेरे भी तो ऑन नहीं हो रहा है। नहीं, नेट नहीं। ये क्या हो गया? करने का भी ऑप्शन नहीं है। ऑप्शन नहीं है।
So now, sorry for the inconvenience. I think he's not connecting with us now due to the technical problems. So now I would like to request Professor Bhupin Singh Vitola from Delhi as a chairperson. Please conclude the session, please. I'm requesting you, sir. Are you listening me, sir? Professor Vitola?
वो फोन नहीं उठा रहा। वो दूसरा सेशन चल रहा
मैसेज कर दिए
है। आगे से मैं किसी का
मैसेज टाइप कर दिए
Professor Butola, sir, are you available? Are you available, sir? Are you available, sir? So again, there is some. So we are not connecting with Professor Bitola from Delhi. So I'm requesting you, Sujan Varghese ma'am, if it is available, Sujan Varghese ma'am, to say a few words, please, about Bhupen Tiwari sir, please, Sujan Varghese ma'am.
Yes, I could not hear you much. But again, overall, about the other two talk, I would like to conclude here. Overall, the recent advances in analytical technique, the conferences which under your initiative, Dr. Shiv, you have taken up, Dr. Ashish and Dr. Neeraja Sharma and other, of course, the organizing committee members. Like today it has been really wonderful to know the various techniques involved with the latest sophisticated analytical techniques, especially with the both the techniques which we use for the nano material characterization as well as the application. So it has been a very useful at the same time when we are worried about how to reduce our waste and convert it into a useful product. Not only that, how to
Om
have
ji,
a
if you are
sustainable
available, sir ko
environment,
allow mat kariye abhi, please.
have to have a sustainable environment. For that, these two, the mornings, both the talks were very informative and insightful. And I definitely believe that all the participants have definitely benefited with the various techniques, instrumentation, procedure, principle, application, along with the way they carried out, the way they delivered the talk was wonderful. So at this moment, once again, I would like to thank Dr. Shivabadye, Dr. Ashish Kumar, and Dr. Neeraja Sharma for giving me also a chance to be with each one of you. And all the best for your wonderful program. Over to you, Shiv.
Thank you so much, ma'am. Stay tuned for validity session also, please, ma'am, for giving 20-25 minutes, please. I'm requesting you, ma'am. So
Okay.
now we are moving for our next as validatory session. So इस विदाई समारोह में हम लोग कुछ बातें करेंगे, जिसमें मैं सबसे पहले इनवाइट करना चाहूंगा प्रोफेसर आरसी पुरोहित, Principal HNV PG College, Khatima, Uttarakhand. Are you available, sir, to say some few words in very stipulated time? Please, sir. Are you available, sir? Dr. RC Purohit, Principal HNV PG College, Khatima, Uttarakhand. So, not connecting, I think so. In this series, I would like to request Dr. Neeraja Sharma, Head of the Department Chemistry, Srivasne College, Aligarh, to say some few words, please. Ma'am, are you available, ma'am? Dr. Neeraja Sharma. Ma'am. Unmute yourself, ma'am. First, unmute yourself.
Okay. हेलो
जी मैम बोलिए आप।
You are audible, ma'am. In 2-3 minutes, you can please, ma'am, please.
okay Shiv, thank you very much for giving me this opportunity to thank a lot to the organizers, to the speakers and all. Respected chief guest of the 2-day conference, Professor Ashok Mittal sir, VC of Dr. Bhimrao Ambedkar University, Agra. All distinguished guests, eminent speaker of both days, and enthusiastic participants. First of all, I congratulate the team behind this amazing and fruitful work. This is a proud moment for all those associated to make this conference a great event in this time of crisis. In these 2 days, we listen about the different techniques, their working, application, and advancement that are must for various research work and there is echo.
Yeah, you can continue, ma'am.
Various research work and field, whether biological science or physical science or analytical fields, nanomaterial study, industrial field, and so on. This conference was organized with the aim to uplift and upgrade and update our knowledge of advances in analytical techniques. And I am sure that all the deliberation help a lot to achieve these motives. So the organizer definitely did a great job, and each participant gained a lot from the interaction with these renowned speakers. I must like to thank our patron-in-chief, Professor Bhuvnesh Gupta, who is always a symbol of inspiration to all of us, and Professor Durgesh Pant, patrons Dr. Pankaj Varshne, CA Atul Kumar Gupta, Professor Pandey, Professor Chandaram, Professor R.C. Purohit, Professor B.D. Upadhyay, and honorary chairs and keynote speakers, Professor Meghna Joshi, Professor Mukesh Kumar Singh, Dr. Menka Jha, Dr. Bhuvnen Tiwari, Dr. Sridhar, who gave a very valuable knowledge about the advancement of the analytical techniques in the field of analytical techniques. Once again, I would like to thank the whole team behind the successful and especially convener Shiv Kumar and organizing secretary Dr. Ashish Kumar and his technical team. I am also thankful to the speakers and participants who are the main stem of this event. So at the end, I congratulate all for such a wonderful conference and hope we will continue to meet again in future. Thank you very much.
Thank you so much, ma'am. Thanks for very kind words. Now I would like Dr. R.C. Purohit, Principal HNV PG College, Khatima, Uttarakhand. Sir, are you available? Say some few words in stipulated time, 2-3 minutes, about outcome of the conference. Sir, please.
On the second and final day of the conference, very good afternoon to all of you. Thank you, Dr. Ashish and Shiv. I am glad that Department of Chemistry Affairs and Department of Program, Sri Vasne College, Aligarh, Dr. Bhimrao Ambedkar University, Agra, Uttar Pradesh, and Division of Molecular Synthesis and Drug Discovery Center of Biomedical Research, Government of Uttar Pradesh, Sanjay Gandhi Postgraduate Institute of Medical Sciences, Campus Lucknow, in collaboration with Uttarakhand Sciences, Education and Research Center, Department of Science and Technology, Government of Uttarakhand, Dehradun, Department of Chemistry, Dadehari, PG College, Kasipur, and Hemati Bhavana, Government PG College, Khatima, Uttarakhand, has organized a two-day national virtual conference in a pandemic period. This time is very panic to every human being because all are thinking about COVID-19. The topic of conference: recent advances in analytical techniques 2020 is very good for all researchers, students, and as well as scientists. Nowadays, these techniques are very useful for preparing vaccines and medicines in every field as well as COVID-19. I am very thankful to our chief guest, Professor Ashok Mittal, Vice Chancellor, Dr. Bhimrao Ambedkar, University Agra, Professor Bhupesh Gupta, Department of Textile and Fiber Engineering, IIT Delhi, President Asian Polymer Association, former Director Research, SMU, and chairpersons of all sessions, all other participants, keynote speakers who delivered their invaluable lectures, which will be beneficial for all. At last, I bless convener Dr. Shivakumar Upadhyay, Dr. Mamta Belwal, and Dr. Ashish Kumar, and the entire organizing team for organizing this national conference very successfully. Once again, thank you all. Thanks.
Sir, thanks a lot for giving a very kind word. Now, in this case, I would request to invite USERC Dehradun is also the part of our organizing of this activity. Sir, I would like to request to say some few words about the outcome of this conference. Sir, are you available? Sir, O.P. Nautiyal, sir.
मीटिंग में है सर, अभी आगे बढ़िए आप।
Now we'll move to invite Professor Bhuvnesh Gupta, our Patron-in-Chief for RAAT 2020. Sir, I welcome you to say some elaborative words for outcome this conference as a chief patron of this national virtual conference RAAT 2020, sir.
Okay. Can you hear me? It's okay?
Yeah, audible, sir, audible.
Okay. So, I would say that I'm really grateful that the organizing committee invited me to be the chief patron for this conference, and especially to look at the various possibilities in organizing it. At the end of this 2 days conference, the valedictory is always very important. It's a tough job also because you have to sum up many things together and to frame them up in a specific direction. First thing which I like to say is that organizing a conference is a very difficult task. It needs a lot of energy, a lot of efforts, and out of these efforts, you come out with a lot of interaction with different places. As I see from this conference, that there was a blending of 4 different institutions together. SV College Aligarh together with Medical College in Lucknow, PG Girls College in Khatima, and DST Uttarakhand. So all to combine them together to make a collaborative project out of it is not a small thing. And this is where I can say, and I can realize that it's the wisdom of Shiva Upadhyay to take up all these things together and make this possible. So in this conference, which has taken only 2 days time, what I see is that organizing this conference is not, again, a small thing, because there are speakers. You have to look at the speakers, quality of the speakers, and which I see here, the way it has been planned. You had speakers from very renowned institutions, IITs, DST institutions from Mohali and other CSR laboratories. So I would say that the quality of the people who are going to deliver their talk, or who deliver their talk, that's also very important. And this has been rightly taken up. And this shows again the creativity of the whole team. It's not one person, but one person may be there at the center, but the way he takes around all the people together, that's his dynamism. So with this dynamism of all the people, you could see so many people, good experts, large number of speakers, large number of chairpersons who are involved in it. And this makes a big difference when you organize an event like this. The conferences, as I visualize, is the center and the platform where so many people come together. See, you carry out your work, you carry out your research, you do excellent research in your laboratories. But unless you tell people that you are doing something, no one will come to know. They may come to know through your publications. But when they see the person in front of them, and look, this person has done this job, the things change completely. And this is what the conferences provide. So my suggestion to this amalgamation of 4 different, because platform which can create a knowledgeable world for young generation. Other students do not know anything. See, these are the men. You are the mentor. People, the mentor can make these young people knowledgeable in their respective area, especially the topics that we selected. Each one of us, whether we are chemists, or we are physicists, or we are biomedical scientists, or material scientists, everyone needs characterization. So, this is a very interesting conference where you can really have a glimpse of how people are working on it, how people are organizing these conference, organize the instrumental aspect of the characterizations. Unless you characterize the material, you can develop anything, but you can't say it's the same material. So this is very interesting, very important topic, which is RAAT 2020, which has been taken up by you people. Certainly, I would say that you have to continue with this effort, and you have to continue involving young generation. I could see the brochure that we have taken out. The brochure has a lot of young students in there. I think you can enthuse them. This is the way you can put them, bring them into the mainstream of this country. And that's what the country needs from you. A teacher is just not a teacher just taking classes. A teacher needs to design and formulate the overall energy, energy of the student in a specific direction. And that's what we people have to do. So this is our job as an elderly faculty. It's our job to show the world of material science characterizations to our young generation. And this is what we are doing very nicely. All the young generation, I tell you, they have ambitions. All students have ambitions. They want to do something great. But then there's no to tell them. Guru Govind do khade kaake lagu paye. Guru has to tell who is Govind. That's where our job is very important. We have to tell people, look, this is the way you have to go. And the world will be there for them and for us. So with this kind of situation where you could do a nice job, I really thank everyone that you could bring out a beautiful show together. with so many eminent scientists from different places in this country, which is not a small thing. And I'm sure that you are going to do the same thing with same energy, same enthusiasm in subsequent years too. So thank you so much for inviting this event. I wish all the best for your success or consecutive events. Thank you.
Thank you so much for your very kind words. Now we will conclude the validity session. I was saying only in 10 minutes, saying vote of thanks with myself as winner of this RAAT 2020. So before I start of my vote of thanks, I would like to say COVID-19 has stopped the life movement, but not the learning. Science is the beautiful gift to the humanity. The science of today is technology of tomorrow. I hope that you learned a lot and made some new contacts. It is my privilege and also very fruitful and amazing time for me to propose vote of thanks in this valedictory ceremony of the most wonderful national virtual conference on recent advances in analytical techniques on 16-17 August 2020, organized by Department of Chemistry and AADP, Srivasne College, Aligarh, Bhimrao Ambedkar University, Agra, and CVMR, PGI Institute of Medical of Science Campus, Lucknow, Uttar Pradesh, in collaboration with Uttarakhand Science Education and Research Center, USERC, Department of Science and Technology, Government of Uttarakhand, Dehradun, Department of Science and Technology, and Department of Chemistry, RH, Government PG College, Kashipur, and Department of Chemistry, Hemmati Nandan Bhagwana PG College, Khatima. It is our honor that we have distinguished guests joining this virtual conference on this special area of analytical sciences. I would like to take this opportunity to express my thanks, and I am highly grateful to our chief guest, Professor Ashok Mittal, Vice Chancellor of Dr. Bhimrao Ambedkar University, Agra, for his blessing and guidance to our delegates. We wish that your words would help in taking the conference newer dimensions. We felt so much delight to have you with all of us and make this event a remarkable one. In this line, we are also thankful to our presence of Patron-in-Chief Professor Bhuvnesh Gupta, Professor Department Textile and Fiber Engineering, IIT Delhi, and Professor Durgesh Pant, Director USERC DST Dehradun, Department of Science and Technology, Uttarakhand, for their inspiring direction in the delegates. We are blessed with your presence and giving your valuable time. Make this occasion more auspicious in the successful and productive event. So please accept my sincere thanks and congratulate on making this national conference a successful one. It is really a great for me to say thankful. I want to express my gratitude for our patrons also. Our youngest principal of Sri Vasne College, Aligarh, Dr. P.K. Vasne, of Sri Vasne College, Aligarh, C. Atul Kumar Gupta, Secretary Management Committee, Sri Vasne College, Aligarh. I want to thank both of them with my soul heart for their continuous support and help and all time. They are always with us and giving their valuable time. Without their support, this virtual conference we successfully completed. Professor Kamal K. Pandey, Principal SVPG College, Professor Ramchand, Principal RH Government PG College, Professor R.C. Prohit, Principal HNV Government PG College, Khatima, Dr. B.D. Upadhyay, Principal Dharamjyoti Degree College, for their valuable thoughts and blessings and insight toward the promotion of research and development through this event was really appreciable. We are also thankful to our honorary chairs of this conference, Professor Mangala Joshi, Professor Vivek Kumar, Professor Ajay Taneja, Professor Mukesh Kumar Singh, for their support make this event a mega event. We are highly obliged with your presence and thankful to you for giving your valuable time, sir. My special thanks Dr. M.C. Vasne, Associate Professor and Chief Proctor Sri Vasne College, Aligarh, Uttar Pradesh. I was to say special thanks to sir, giving a very wonderful vote of thanks in the inaugural ceremony of this conference by making a guldasta of all the organizers. I would also like to say my special thanks Dr. O.P. Nautiyal, Scientist USERC Dehradun, Uttarakhand, to take care all the activities and provide all type of full support by USERC regarding this virtual conference. We also thank to our conference Yes, Dr. Neerja Sharma, HOD Department Chemistry, Vasne College, Aligarh. Dr. Bhupen Tiwari, Associate Professor, Center for Biomedical Research, CBMR, Lucknow, Uttar Pradesh, for their valuable and very informative address and kind word to delegate, which will open a new pathway of this conference organization. I am highly thankful to our conference co-chairs, Professor Bhanu Nandan and Professor Rajiv Srivastav from IIT Delhi. Dr. Sujan Varghese, HOD Department, St. John's College, Agra. Dr. Dilip Gupta, Associate Professor, DS College, Aligarh, for their valuable time. And really, we are highly honored to have you all part of this national virtual conference. I would like to thank all our plenary speakers, Professor Mangala Joshi, from Professor Mukesh Kumar Singh, Director UPTTI Kanpur. I would also like to thank our speaker, Dr. Menka Jha, Scientist, CINST Mohali, Dr. Bhupen Tiwari, Associate Professor, CBMR, and Dr. B. Sridhar, Senior Principal Scientist, Hyderabad, giving their time. And presentation given by all the speakers was full of knowledgeable and was really helpful in the understanding the various analytical techniques used in the field of research and development. This dissemination of knowledge will be highly helpful to the participant and open to new channel to the interact with these eminent personalities. I would like to thank our convener, Dr. Mamta Benwal, Assistant Professor, Department of Chemistry, RSPG College, Kasipur, Uttarakhand, for her continuous support and efforts. In this series of vote of thanks, I would also like thank our co-conveners, Dr. Jyoti Agrawal, HOD Department, Chemistry, HNV College, Khatima, US Nagar, Uttarakhand, and Dr. Tarun, especially my vote of thanks to Dr. Tarun Kumar, Executive Director, MIT Kumayu Haldwani, for being with all time with us and take all responsibility from that side. I would also like to thank for dynamic and creative organized secretary, Dr. Ashish Kumar, Assistant Professor, Department Chemistry, HNV Government PG College, Khatima. Very creative and inspired Dr. Neha Gupta, Assistant Professor, Department of Chemistry, Lajpat Rai College, Saibabad, Uttar Pradesh. She is very active and always available for doing some activities. Dr. Chetna Verma, Senior Scientist, Department of Textile and Fiber Engineering, IIT Delhi. Without whom this event will not be possible. Really, thanks to all of you for your tireless efforts and with me, your full of support. I would also like to thank our student coordinator, Mr. Chandrakant Sharma, Ms. Ankita Sharma, Prachi Upadhyay, Ms. Ava, for the continuous help and support. I would also like thank all the advisory committee members and their presence and support. I would also like thank for their members of organizing committee for their efforts and valuable support. A special thanks to member of organizing committee, Dr. Manoj Kumar Sharma from SB College, Aligarh, Dr. Mahib Kumar, for their continuous help and full of support in all time. I would also like to thank technical committee members without whom this event cannot be proceed. It is my great pleasure to say special thanks to Mr. Om Joshi and here entire team members, Mr. Umesh Joshi and Mr. Rajdeep Jagandu. From the core of my heart, I give my strong technical support to smoothly conduct for this event. I really feel thankful for the continuous support. I am also thankful to all student committee members for their help and support. I would also like to thank all the invitees and special invitees for this conference who are during with us and grace the occasion with the presence. Last but not least, I would like to thank all the participants across the country without whom this event will not be conducted. Thanks to all of you to be here with us these 2 days. Listen by patiently. I hope you all were benefited to lot by attending the sessions, which are going to highly informative in terms of science and technology of different materials. I am highly grateful to Sri Vasne College, Aligarh, CBMR SGPC Institute of Medical Science, Lucknow, and USCRC DST Uttarakhand, and RH Government PG College and HNV College, Khatima, Uttarakhand, for make this more successful by joint activity. I am sure this event is going to be a highly informative in terms of science and technology of different materials, and we look forward very creative interaction all the delegates. We are highly regretted for some of the technical glitches occurred during the sessions. We are hope you all will understand some of the limitations of e-platform. Inconvenience is highly regretted, and thanks to all of you for making this event so wonderful. So at the end, I hope you all will enjoy all the sessions, and I once again thanks to all of you. At last, I would like to thank all the contributors who are contributed directly or indirectly for this national virtual conference. Stay home, stay safe. I once again thank you so much to all. Over to Om Joshi ji, please. To end the session.